Recording?
Go ahead.
Well, welcome to the March 9th, 2021 session of uh, Tangerine SDR and HamSci technical meeting. So this week I've been doing two things. I was working on the Tangerine simulator and I've gotten a basic start and I've been going through protocols like crazy. So I have a whole bunch of questions for Bill, but we can leave those for at some point. And but I'm making some progress on getting the pieces together to build the protocol for the programming part of setting up the Tangerine. So it's coming together. Also, I'm involved with Tapper, and Tapper's been trying to update their Whisper transmitters. There's a small glitch that they work with Raspberry Pis 2s and 3s, and they do not work with Raspberry Pi 4s. But we think we have all the necessary changes. So I've been working with Bruce on that. And also George is involved and Dave is a little bit involved. So it's an interesting little side project. So that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. It's been a busy week for me. Getting ready for the HamSci workshop, and this weekend I went through and got the schedule updated pretty much as possible. I think it's almost complete. A few more details are filling in, but I think we're off to a good workshop. So very exciting. W2NF, back to net.
The flyer you sent out was quite nice. So
Thank you.
Good. Next on the list, we have John in 8 OBJ. Go ahead, John.
Kind of a busy week. I got the parts list. I believe I mentioned that last week for the Grape up on the website. I also got the entire listing of parts you need to purchase to put the whole system together up there, including links on Amazon to buy everything. Started in earnest on working on the antenna that I bought 2 of, Super Speedo Quicko from Nathaniel. A magnetic antenna's direction pointing is orthogonal to common sense direction. It's not what you think. I'll leave it at that. I'm in the process of trying to set that up in the backyard, but yesterday it was only had a high of 31 degrees. So I waited today, and I have just starting to get started on that. Looks like you have to place it at a minimum of 5 feet above the ground. So I'm going to try that first and see how well that works. I started looking at the A to D for the Grape 2 and discovered the one I picked uses I2S bus, which would take over the I2C bus that Scotty is using, and I'm sure he would shoot me if I did that. So I'm now redoing that and looking at another A to D possibility. I sent out a document to John Ackerman and Scotty about the clock requirements I have. The only thing we haven't resolved yet is I have an 8 kilohertz start A to D conversion clock that I have to come up with that has to be super accurate. And I've used up the 4 outputs for the 4 synthesizers and the 1 PPS. And the comm link is indeed a UART as Scotty thought it was. But we have to figure out how to get an accurate 8 kilohertz sample clock, because that affects what frequency you actually measure, because that's the sample time. So other than that, back to net.
Fine business. John, could you put a link in the list for Joe, who wanted where he could find out more about your grape?
Yeah, I'll send him some wine.
Okay. Very good. Next on the list, we have Dan in 4XWE. Go ahead, Dan.
Thank you, Dave, and good evening, everyone. Not a lot to report. I did happen to get my first COVID vaccine shot last week. So I'm on the way to better life, I guess. So, so anyway, that's about it from here. Back to you, Dave.
Fine business. I had to take my wife in to get her second one, and
I'm
so
jealous.
that was Saturday, and I still have 2 weeks before my second one. So
Yeah,
anyway,
Ohio just opened up 60 last week, and then this morning they opened it up down to 50. So it's a total, yeah. I'm not going to be getting one for a while.
Yeah. Well, I'm appreciating being still associated with the university, that they have facilities here that are doing a nice job.
Yeah, so does Case, but we're not allowed to get shots there. So.
Oh, okay. Next on the list, we have Bill, AB4EJ. Go ahead, Bill. Sorry about your trees.
Okay, yeah, thanks, Dave. Other than walking around my property and looking at all the pine trees that go up about 50 feet and then they go up at an angle like this and leaning towards the power line. All I've been doing, well, let's see, I worked a little bit on preparing the talk to give at HamSci. Also, I've got the Grape interfaced with the GPS receiver so that when it starts, it can talk to the GPS receiver hat and find out the time and date, and can automatically assign the correct time and date to the digital RF files. And because that's important to know the exact time. And it also saves the latitude and longitude in the digital RF metadata. So we've got that to where that works automatically. And so I guess that's probably about it for this week. Back to Ned.
Well, fine business. And next on the list, we have Dave Witten, KD0EAG. Go ahead, Dave.
Hello. Nothing I care to report. So that's it. Back to you.
Fine business. And then next on the list, we have Cuong Gaming. Go ahead.
I think his name's Cuong.
Cuong Gaming. Okay.
Cuong Yang.
Oh,
sorry
about that.
I'm phonetically pronouncing it. Sorry. Cuong?
Yeah, it's all right. Yeah, it's
okay.
Wing.
Go ahead.
So, well, aside from, you say something?
Go ahead and whatever you've done relative to this or are interested in or whatever you want to ask.
Oh, okay. Well, yeah, aside from schoolwork, I was still learning about the FPGA. I started to do a few more little projects. I started learning about a little more about structural coding, I think that's what it's called, and behavior coding. And I tried to connect the FPGA to an Arduino to play around with both of them at the same time, but I haven't succeeded in doing that yet. So I think that's pretty much it.
Okay, very good. Next on the list, we have David N1HAC. Go ahead, David.
Good evening, everyone. Really busy right now getting ready for a sounding rocket. Looks like I'll be going down to Wallops next week, put an instrument in, getting ready to, this is a VLF propagation experiment being launched from Wallops. So doing some groundwork and putting the payload together, and yeah, it's getting interesting. And then yeah, we've been working with Claire Trope, who's going to be giving our talk for HamSci on our AM Doppler project, which is showing some very interesting results. And we're going to be interested to see how that how people see that connecting with the WWV experiments and whatever else is going on. So back to net.
Very good. Next on the list, we have Dev, KC3 PVE. Go ahead, Dev.
Hello, good evening, everyone. So we're starting a new week at the University of Wisconsin here. We're preparing from the HAMSI workshop 2021. Nathan is working towards that in full gear. And I'm also trying to present if I can detect irregularities in the ionograms that I had processed with the data we collected here at the University of Wisconsin, at Nathaniel's house. So we are looking at TIDs and we're also looking at irregularities, and we'll later on we aim to see if we can discuss about the sources of these to process if how they are connected, how they could possibly be connected, or they could be not connected. Thank you.
Very good. Next on the list, we have Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just sitting here copying the mail, trying to stay current. Back to net.
You look like you're in Svalbard.
Reykjavik,
Okay,
not far.
very good. Okay, next on the list, we have Human. Go ahead, Human. KD2M CR. Go ahead.
Okay, good evening, everybody. I've been working on data itself. I have downloaded data from the magnetometer that we installed at JennyJump, and along with the data from the real science magnetometer co-located there. So I'm in the process of comparing those data sets in preparation for the HAMSI meeting. And also in the lab, I brought the magnetometer to sort of characterize the noise performance, noise, and then the resolution performance in the lab. I just wanted to see how that performs in more detail. So that's what I'm working on right now. I'm working on plotting. So I'd like to, hopefully I can share those plots with you guys sometime soon. Back to net.
Very good. Next on the list, we have James, KG4 DSG. Go ahead.
You got me now?
Yep.
Okay. Just reading the mail, trying to stay current with the list. I did have a question that can be addressed at the open discussion about digital RF and building from source. And I'll just defer that until the discussion point. I'm looking for some assistance. Back to net.
You should be able to find it in this group. So next on the list, we have J, WB8 SBI. Go ahead, Jay.
Hang on, I'm there. I'm coming. Hi there. Just
hello.
The laptop was a little bit slow tonight. Other than having received Moderna dose number 2 today, nothing else going on around here.
Well, very good.
So, just looking forward to the upcoming HAMSI 2-day event, which I am registered to, and this and also the upcoming QSO today all weekend event. So Nathaniel, I'm really looking forward to this year's your presentations this year. So otherwise, that's all from up here in Michigan.
Very good. So next on the list, we have Jim K4 BSE. Go ahead, Jim.
Good evening, Ned. Well, I haven't gotten a lot done because I had to get my taxes out, but they're in the mail now to the accountant. And so I got a little bit of time coming up. I did spend some time trying to duplicate the experiment of separating WWV from WWVH by using the time ticks. And it turns out not to be as easy as I thought it might have been. I was able finally to capture one very good sample, which I was able to make measurements on the time delay between the two. It was about 18 milliseconds, which is about right for my QTH. I've got to double check the exact numbers, which I didn't have time to do, but it looks like about right. I was also trying to bring up VOICAP to read, to look at some propagation issues from those two stations and others down to the South Pole area. I have not had really time to work on that. Downloaded it, but I had a problem installing it, and so I'll get back to that probably now that my taxes are in. Back to Net.
Well, fine business. And next on the list, we have, let me see, Joe, W7LUX. Go ahead, Joe.
Okay. No, I'm unmuted. Okay. Am I unmuted?
Nope, we can hear you.
Okay, fine. Let me think. Just got my second COVID shot here a couple of weeks ago. So courtesy of the VA and more years than I care to admit to. But a couple of weeks ago, Scotty asked me if I could measure phase noise. And so I've been working on building up a backup facility to do exactly that. Looks like I will be able to measure phase noise down to the requirements before very long. Other than that, very much enjoying the meetings here.
Very good. So next, let's see, we had John. So it's Jonathan, KC3 EEY is next.
Hi, everybody. I wanted to take a look at the direction of the design of the VLF module. So I reached out to some people in the meeting today, Scotty, Tom, David, and John, because I was unsure of the direction of the design, because I felt the way that it was I guess you could say over-engineered or unnecessary to have this high bandwidth SDR used with VLF data. But after talking with Tom, I kind of missed the whole point of the VLF data being made available to anybody who needs it. So with that, I had some questions about how it's going to be handled, and if anybody thought about what's going to happen to it after it leaves the SDR. Whether we're going to use vlfrx tools to deal with it, which I think we should, or if we convert it into another format like a digital RF. But I don't have any experience with that, and I haven't written any programs. So I would much prefer to utilize vlfrx tools as much as possible, because I think that they have a greater benefit to the community. So with that, I was wondering what will be sent to a central control in terms of VLF data. Is it going to be the streams? Is it going to be events only, like whistlers or SIDS? And how is it going to be handled? So that was my question to the Brain Trust, because that's something that I really didn't think about. So if you guys have any tips or information or any, what you guys think, let me know. Other than that, back to the net.
Well, fine business, Jonathan. Why don't we leave that question for a discussion during the general session? I want a couple more people and we're finished with the list. So next on the list, we have Michael, AA8K. Go ahead, Michael.
Thank you. Greetings to everyone on the conference. Back to you, Dave.
Fine business. And next on the list is Scotty, W2DFI. Go ahead, Scotty.
Okay, can you hear me now?
Yes, we can hear you now.
Can you hear me now? Thanks, Dave. Yeah, it's been a really busy week this week, and the good news has been mostly all on ham-sci Tangerine stuff. So I did a poster for the upcoming Ham Expo, and there's going to be on display in the, I think in the ORI booth or the ground station booth, because there's a whole story on why AMSAT's not going to be there, but it's going to be in the space arena. So it's going to be more of a focus on the space weather rather than the Tangerine hardware itself. So, and I sent that to you, Nathaniel. So I'd like comments to see if you think it's a good one for, I only have, I think there's 10 slides, 10 little thumbnails, and only a couple of them are on the actual hardware. The rest is on what measurements are we going to do with the hardware that we've got. So, and one thing I want to remind those people who are not going to be on daylight savings time next week, that the meeting time will change because we go on daylight savings a week from Saturday. I mean, this Saturday. So we switch. So for Joe and I, at least on here, will definitely be switching to 6 o'clock instead of 7 o'clock local time, because we're the only sane ones that stay normal. You guys all switch times all over the place and nobody can keep track of where you are. So let's see, next we got the image for the data engine. I have an image for the data engine preliminary placement. It's done. The CAD guys got it done. So during the general time, I can show that to you if the people who are interested. And we got the clock. I got the clock module production schematic finished. We haven't reviewed it, but I've got it completed enough that we got a good read into the CAD guy. So now I have the data engine, the RF module, and the clock module all read in, and we'll be able to place things together. We already have shown that the RF modules and the data engine go together, and we did find some interference issues. So Tom, you and I are going to have to talk about that. I think we're going to have to move some of the diodes that are on the back that are the protection diodes for the relays. So this is like nothing to do with RF, but they have to be moved over because there's some through-hole parts that come through, and they probably won't interfere, but I don't like probably. I want to make sure definitely. And since the boards kind of will be able to move a little bit when you're inserting them, I don't want to tear parts off the board when you're sliding parts together. So we may end up doing that, but that's the whole purpose of having CAD models of all three boards, so that we can see where the parts are on the boards, and and we have all the parts that we built for the boards have a Z dimension, so we know how tall they are. So the boards we can actually create an AutoCAD model for each board with an envelope, if you will. So when we plug them together, turn them this way, we can see, well, are the tall parts going to hit the tall parts? Are they going to slide past each other? Is there enough room? And it's pretty useful to avoid problems. So that's a lot of progress on the data engine and the clock module. I also started on some test fixtures for the data engine because I suppose that we're going to test Tom, we're going to test the RF board by plugging one into a data engine, and we're going to test the clock module by plugging one into a data engine. But how are we going to test the data engine? So what I've done is I'm having the CAD guy build some little paddle boards that are clock module and leaf boards and RF modules that just have a connector on them that loop back pins to pins. So you just plug them in, and then you put a special program in the FPGA that runs patterns through the outputs and looks for the inputs to detect shorted and open pins. One of the ways that I did it on the HPSDR project, all those FPGAs that we built on those boards had test codes, that test code versions that I could load into the FPGA, plug a bunch of loopback plugs on the board, and then run the program. And we got lots of LEDs so they can come up and flash or come on red or green or tell us whether we passed or not. And the FPGA image, I'm working on the pinout of that right now too. I did find some problems with it that I corrected on the data engine. I still want to make sure that we're going to be okay with it. But because what we have to do is we have to assign the pins based upon the schematic of the data engine, but we also have to assign the pins on what's going to be plugged in, because since the pins are programmable, I want to connect them up so they will actually talk to an RF module. And we reprogram some of those pins to do different things on the RF module other than just data, because we have some I2C and an I2C port and things like that. So, and it looks like, Tom, I think we're going to have to use CMOS interface to the A to D, because the LVDS, the Altera only supports LVDS on 2.5 volt buses, and all the IOs are 1.8 volts. So I'm looking at the interface now, trying to figure out how to program the FPGA to talk to the A to Ds, and I don't think I can set them to 2.5 volts. I mean, I could do it, but I don't think it'd be very healthy for the A to D converter. So we need to look at that and see if we can figure out a way to make this work the best way. And that is about it for this week. So back to you, Dave.
Well, fine business. And the next on the list is Tom in 5EG. Go ahead, Tom.
Good evening. It's been a week full of email to lots and lots of different folks on lots of aspects of the project. So most of those have been resolved offline. Back to the group.
Well, fine business. And so at this point, if I haven't missed somebody, we're open for general discussion.
If I could jump in here, what Scotty was just talking about, if at all possible, please do it LVDS. CMOS levels create a tremendous amount of RF hash.
Yes.
Well, I mean, we could try it. And what I've heard is rumors are, and I don't particularly like this solution, but hey, you have to use what works, right? The rumor has it that you could set the IOs to LVDS and set the IO voltage to 1.8, and it will work anyway. Even though it's not really in the LVDS spec, it still will fall close enough into the spec as far as the current for low and high that it'll still work.
Yeah,
I've actually heard of people doing it the other way and setting the voltage to 3.3 and setting it to LVDS, but I've never heard of them going to 1.8. So
yeah, we need to check the specs of the transmitters and receivers there.
Yeah, the A to D converter levels, I think I'll have to check the CMOS. I think the CMOS levels are 1.8 volts also, because I'll have to check the schematic. My recollection is the part only has a 1.8 volt supply line.
That's right.
Right. So
and it doesn't have an IO supply line?
I don't think so. I'll have to check.
Okay. Yeah, we need to check that.
It does, but it's limited to 2 volts. So
yeah, the LVDS has to operate at double the clock rate. So it operates at 245 megabits per second per lane. So it's running DDR, and I can move the clock edge plus or minus 4 nanoseconds on the clock. So I can center up the front half eye and the back half eye, but they have to be LVDS to keep those eyes open at 245 megabits.
Right.
But Tom, we have 2 buses there. So if you run them at CMOS levels, then you're going to be running them at only 122 megahertz, correct?
They share the exact same pins. So what happens is that the same number of pins are used. They operate at the same 1.8 volt voltage level, but instead of being differential pins, they're now single-ended pins operating at 122.88 CMOS.
Right.
Right. But as David said, you know, the noise level just absolutely goes through the roof when you do that.
Yeah.
And it doesn't have anything like like random, like the 2208 has, right?
There is a little bit of randomization, but I think it's only for a couple of LSBs. I don't think it's the entire data word. Still, you cannot rely on randomizing the data word to get rid of the noise, because statistically, you'll have pins, enough pins moving at the same time that you'll get significant noise density.
Do we need to just put in level translators?
Well, those would have to go on the data engine itself.
Yeah.
Yeah, and that would be, first of all, it would be a lot of area. Second of all, the question would be, is that really going to reduce the noise? Because if I ended up having to run CMOS on the FPGA, then I haven't really saved a lot, except made the traces shorter.
Yeah, they'd be much shorter at that point.
Yeah. So, but the thing is, we can run the bus at one point. We have to run the bus at 1.8 because the voltage maximum on the A to Ds is 1.8. However, but that's the thing is, since the A to Ds we're hooking to the outputs of the A to D, I would think that I could possibly make the bus run at 2.5 volts because I'm really looking for current. I mean, the voltages are only 0.6 of a volt difference between high and low on LVDS. So that would be fine, except the problem is we have other IO pins that connect, control pins that connect to that bus that are not going to like 2.5 volts because all of the IO on that part's 1.8. So maybe we put some level translators on those few pins.
Okay, all the pins you're talking about are outputs from the A to D. The A to D is driving them to 1.8 volts and to ground or whatever the LVDS levels are. Those are all outputs.
What about there's an I2C bus and there's some other control pins. Those are all outputs, well, except for the I2C. It's open collector, but so that doesn't matter.
The part has an SPI with a bidirectional and 3-wire SPI at 1.8 volts IO. And all the I2C are discrete parts on the board. They don't go through the things that turn the relays on and off, don't go through the A to D converter part.
So we may actually be able to run program the FPGA to 2.5 and set the IOs to LVDS, and it will work fine with a 1.8 volt bus.
I don't know. When you run them at 245 megabits per second, margin is not very great.
The thing is,
yeah, but with LVDI, it's differential and it has common mode rejection, so it should have a fairly wide compliance on the LVDS inputs.
Depends on where the center voltage is, because that'll change by setting it to 1.8 or 2.5.
Right.
It'll move it. So, and that's probably the biggest thing it'll do to move it. I suspect that the peak to peak value won't change much between 1.8 and 2.5. It's just it'll be moved down in the spectrum. So the common mode,
correct,
hopefully will take care of it. We don't know.
Yeah, interesting. Yeah, I've got a TI based system in Altera FPGA that I can look at, see how they did it.
Yeah, do they have a 1.8 volt A to D?
I don't remember what voltage interface it is.
So Scotty, you're saying that the FPGA doesn't have 1.8 volt differential inputs?
It has 1.8 volt differential inputs, but it doesn't do the LVDS standard at 1.8 volts. It requires, and we can strap the VCCIO of the FPGA to 1.8, 2.5, or 3.3. That's adjustable. However, all of the IOs of that bank go to that voltage. So, so if you need a mix, then you're stuck. However, since all the inputs are 3 volt tolerant on the FPGA, 3.3 volt tolerant, so since they're all outputs of the A to D, strapping the FPGA for 2.5 is not going to break anything. I mean, it might not work, but it's not going to burn anything out because they're all inputs. So,
yeah, I don't know. We're running a real high speed double data rate bus, and you know, if we run it into a weird voltage, hard to know what's going to happen.
But LVDS,
the ADC is on the RF card, right?
Yes.
Yes.
And it's being interfaced directly to the FPGA.
Yes.
On the data engine.
Yeah, it's got a pair. It's got a pair of 14-bit outputs plus overrange.
Right.
And those are multiplexed onto a common set of pins.
Yeah, I know how that works.
Anyway,
So
we
there are
have-
nodes buffers in between.
No,
Direct
they go straight from the part to the
Okay.
connector.
I trust the schematics are on the GitHub.
they're not there yet because they're not completed.
Oh,
It will be.
well, if you could send me the part numbers so I can look at the sheets.
Yeah,
I can
Scotty,
take a look at that.
Can you send David the schematics?
Yeah, I can do that.
Yeah, send me what you have.
Well, Scotty, if you could also send me the I2C interface for the magnetometer and temperature sensors. I want to incorporate that in my schematic as well.
Okay, from the data engine?
I'm
not sure what you're asking for.
I don't think you need the data engine.
No, I want to talk to the remote unit.
Because the magnetometer schematic's already up on the Tangerine page.
Oh, it is, okay.
So you can get that if you want to see how we did it on the magnetometer itself.
No, actually, I'm at the other end of it that talks to what's going out there. So,
well, so on that board, the Raspberry Pi talks to it.
Right.
And on the data engine, all I have is a couple of pins from a couple of open collector program pins from the 1.5 volt bank of the FPGA. So I just basically have pull-ups to 3.3 and outputs connected to the FPGA, and they just get programmed as output open collector.
Okay.
I mean, you can look at it. I'll be happy to send you the schematic and you can look at it.
That'd probably be helpful. That way I wouldn't have to digging around.
And then you'll have the pinout of the connector that I made. So if
Yeah, that would be helpful too. That's
Yeah.
kind of important.
Okay.
Also to Nathaniel, I got Christina a Pi 4B with a heat sink that will work at the South Pole.
Oh, nice. That sounds good.
So she's all happy.
Wonderful.
You need a heat sink if you're at the South Pole. Can't you just open the door?
Yeah. So
Stick it in the snow.
what is special about this one, John?
Well, it's all aluminum, and without the fans on it, I got a 20C rise in ambient. I put the fans on, it drops to about a 7 C rise. But since you have to really rely on radiational cooling down on the South Pole, since the air's so cold and thin, I took the fans off. So a 20C rise from ambient there is going to be no problem.
Right.
Because even here, it only takes it up to 40C. Down there, it'll probably take it up to 10C.
Right.
So
We've
it solves your problem.
We've got a vault you can put it in that's at -40.
Murder.
John, just FYI, just to test it out, I've ordered a Raspberry Pi for a case that it bonds thermally to. It's shaped in such a way that it can bond thermally to the processor chip, but you can also plug into the pins. It allows you clearance to get to the pins.
That's exactly what I gave to Christina today.
Okay, so we'll have 2 of them.
Yep.
So Nathaniel, do you have perhaps anyone available to discuss the space weather aspects of this project at Ham Expo this weekend?
This coming weekend?
Yes, and I'm not sure the exact times, but there's supposed to be like it's kind of like a booth where the posters will be available, and people can come and go, and they can ask questions. And while I can answer questions on the Tangerine, I'm not sure that I'm qualified to answer a lot of ham sci questions on the space weather. I may be in a little over my head there.
Can you let me know what time?
Yeah, I can do
Find
that.
out the times.
So
Yeah.
probably
Maybe we can.
Yeah, I don't need a Phil Erickson type, but you need somebody maybe a little more versed than I am.
Okay.
Well,
I'm wondering if I might be able to step in and do some of that.
Okay.
Yeah, because that is a pretty high level thing. So I just
Supposed
sent.
to be 20,000 visitors.
Yeah, it
So-
probably would be a good thing for me to try to be there. Is that Saturday or Sunday?
It's Saturday, I believe.
Okay.
I can, while the discussion is going on, I can.
Yeah. So I just sent you back some comments on the slides.
Oh, okay.
I liked it a lot. My main comment was a few of the slides that you had on there, they came from ideas that we had early on in the project that never really took off. So they're perhaps more aspirational than they
Oh,
are.
because I did steal them from the early slide decks. So
Yeah, so some of the things like lightning detectors and rheometers, I think the hardware is potentially capable of, but we don't really have anyone actively developing those applications. So,
well, Jonathan maybe for the lightning detector, right? But
well, Jonathan, I mean, maybe, but Jonathan's real interest is more in VLF. So you might, instead of putting down lightning detector, you might ask Jonathan very nicely to send you a slide on VLF science instead.
Well, this I put together about a half hour after the deadline. So it was like I was just going to blow it off because I said I just don't have time to make this up.
Yeah.
But my arm was twisted severely with the amount of people who are going to show up to say you really need to do this. So so I put this together as best I could, but yeah. So
is it changeable or is it
not changeable now for this event because the event's in like 5 days.
Oh,
4
okay.
days.
Well, I guess so.
But I want to change it for future events. And like for the HamSci workshop, this would be a starting point for where I would put something together. But probably I won't be doing this. I'll be doing the Tangerine.
Well, I guess what we can say if people ask about those things is we can say these are things that the hardware is capable of, and we're looking for community interests to help develop those particular applications.
Okay.
And for the other things, things like the ionosonde receiver, we're not actually an active transmitting ionosonde, but we are an ionosonde receiver. We are actively developing that, and I put a few other notes in my.
But I think there's a lot of people who will see HamSci for the first time at this conference. So
yeah,
I hope this doesn't mislead them too much to think that we might be doing all of these things. But
yeah.
But kind of hey, what are we going to look at? And these are the things we could look at. So maybe that's the way to phrase it. I think that's what you said.
Yeah, I think that's a good way to put it. And certainly some of those things, some of those things are active areas of interest for people associated with HamSci, and so they could potentially get done. So
yeah, I noticed that the rheometer, whatever you call it, that site in Sweden, I think that's gone. That web page is gone. So I took the link off because it didn't work. So
yeah,
but there was a URL on the slide.
Okay.
So maybe if we're going to do anything with that, this needs refreshing, I guess, is what the bottom line is.
Yeah. So I think maybe now is a good time to transition into what Jonathan was asking about earlier.
Well, before I want to talk about that, for lightning detection, that is well within my scope because vlfrx tools has utilities for worldwide lightning detection. You just need more than 3 receivers to get accurate calculations.
Jonathan, could you explain what vlfrx tools is? I'm not familiar with that, but you seem to be very wedded to it.
So vlfrx tools is a open source tool set for processing VLF signals. Normally these you would connect your VLF receivers to your computer sound card on a computer running Linux or FreeBSD or something like that. And it has a bunch of utility programs to capture the audio from the sound card. Let's see what else here. It captures audio from the sound card, does GPS timestamping, filtering, whistler detection, chorus detection, detection of sudden ionospheric disturbances. There's a bunch of tools used for lightning detection, and a bunch of different utility programs for a general signal analysis. It was written by a fellow in England. By his name is Paul Nicholson, it is I think it's the definitive tool set for processing of VLF signals. He has a wonderful documentation page, and that it goes in depth of what it's capable of. And I think using vlfrx tools is of interest to the ham-sci community for VLF processing.
How well do you think that'll integrate with the Tangerine?
Well, since these are utility programs, they can be used to, well, they have a basic, ring buffer input and output. They could read from files.
But can it take data from arbitrary systems, or do you have to be using something that looks like a sound card?
Well, normally, well, let's see. Paul does have a utility to read from an RTL dongle, but for most of the VLF signal processing, it's done through a sound card, and the reason for that is that Paul believes that a sound card is an ideal VLF data acquisition system. That's why that he wanted to use it.
Well, is that a generic sound card or a high-speed sound card?
It can be any, depending on the what you're looking for. If you're looking for higher sampling rates and better quality, or if you just want something to capture whistles and chorus, you could use a run-of-the-mill sound card.
Right, but that if you use run-of-the-mill, you're limited to just whistlers and chorus. A lot of our other work is much higher sample or carrier frequency.
Right, yeah, that's why you could use higher end sound cards. Paul uses that Behringer 404. Other members of the VLF group that I'm in use the Behringer 202 that has the Cirrus Logic DAC in it. Yeah, you could use anything you want depending on your application.
Yeah, well, especially if he's got it set up so that he can take data from the RTL-SDR, we should be able to get it so that if we create a good front end, it can take data from the TangerineSDR. We're just feeding it data.
One thing that was occurring to me while Jonathan was speaking up, I've got the the TangerineSDR puts out IQ samples, but it's very straightforward to feed that through GNU radio and convert it over to anything you want, and outputting it through an audio sync, for example, and spitting it out to something else like vlfrx tools. That'd be a fun project, actually.
Yeah.
To see if we could interface that.
In fact, just as a general thing, being able to get it into standard formats like WAV file. Any of our data would be useful.
Yeah, I mean, I'm sure I can do that. In fact, what might be even more fun would be to make an out-of-tree module for a new radio that has a vlfrx tools embedded in it.
Mm-hmm.
So, yeah, there's a project for. Oh, is Tom McDermott
Graduate
still
student.
there?
Yeah. Exercise for the student.
Yeah, it should be possible.
For reference, I posted the link to vlfrx tools on his website. He also has live streams of VLF receivers. Yeah, so I was thinking, or how I originally had thought of this was, I would output a stream that I could feed directly into vlfrx tools. There's a utility program called VTCat, and that takes data from a network socket or another ring buffer, and allows you to move it anywhere you want. So the goal was to take the network stream, the socket coming from the Tangerine, and feed it into VTCat, and then from there through a ring buffer, you could feed it through VT filter to filter out the mains and any interference, and then from there it could go anywhere within his tool set, and you have the ability to dump this data to files, extract WAV files, convert WAV files back into BT files, what he uses. It's a very versatile tool set, and you can pretty much do anything with it. That's why that I feel that it's best for this use.
Well, you know, I don't know if it's open source where you can go in and make mods to it, but one thing that occurs to me is one thing we might consider is writing another module to add to the package so that it can take the IQ data stream directly without having to go through all the trouble of converting it to WAV file and then reading it into something else. So just something to consider.
Yep.
I think that's a good approach. I guess the question is like, what exactly is the purpose of putting it through vlfrx tools, and if it's specialized processing for VLF signals, that's very customized, and also for allowing it to easily be exported to the existing VLF community. I think that's all very good. But I do think it does make sense to take a look at taking it as an open source package and integrating it into the overall Tangerine software architecture.
Yeah,
So still be using that code, but be in an integrated sense.
Yeah, and I think one of the things you were proposing, Jonathan, was possibility of having a standalone VLF system separate from Tangerine, and I think that's not a good idea. I think we want something that's all integrated in a common data stream. Otherwise, it's not going to get installed. Not to the same density, shall we say, of Tangerine SDRs.
Well, right. Because, well, what I was thinking with that was to develop the a leaf module board and make that compatible with the Raspberry Pi as a sound card. That's going to require some more work, and the other other alternative is to work on a design that's a separate sound card for the Raspberry Pi. But that was something on the back burner once this board is all hashed out.
Yeah.
Yeah,
You
it's
could
like,
conceivably have take this card and then come up with a separate kind of like, you know, the reduced space weather station, have basically a sound card interface portion that you plug the A to D card into, and then you don't need the full Tangerine SDR to use that card, but it's still, you know, makes use of the Tangerine development.
Yeah, I think that makes a lot of sense because even the magnetometer is kind of a similar situation. You can
Right.
run the magnetometer just with the Raspberry Pi and you don't need the whole Tangerine. However, it can be, because it's a modular design, it can be folded into the full Tangerine personal space weather station ecosystem.
Because you can run the code on the Raspberry Pi and just plug the magnetometer on and not have a data engine at all, but you
Yeah.
still have all the software.
Right.
I got to run, guys, so catch you all later.
Okay.
I wanted to mention
Thank you, John.
before we move too far along here that we missed Greg on the roll call.
Oh. Greg, do you have anything to say?
Oh, just that I'm looking forward to the workshop. And yeah, I guess you could miss me, but don't miss Nathaniel and Scotty.
Well, we don't. I was hoping you'd pipe up when I asked. Did I miss
I didn't
anybody?
want to rock the boat. I'm new, so. Yeah.
Oh.
I only want to be missed if you have a firearm.
Well, I think that the trick is with these Zoom calls, the roster moves around as people are speaking.
That's the problem.
So the poor person who has to do roll calls has to like keep track of everyone they've talked to and then keep hunting through the list for new people as it's moving under your feet, and it's not easy to do.
Yeah.
Well, if we're between things, do we want to try and touch on the questions that Dave had regarding the interface before Dave has to leave?
Well, yes, I had a couple questions. I've spent, it's been 5 or 6 years since I worked a lot on OpenHPSDR. And I went back and reread Protocol 1 and manuals and Protocol 2 manuals. And Protocol 1's about 30 pages and Protocol 2 is about 84 pages. And I realized it's full of stuff that we don't need, we aren't going to use. It's not really relevant.
Hey, Dave, I took that 84-page document and I was going to convert it for our use.
Yeah.
Out that I could rip out about 80 pages of it.
Yep. So what I'm doing right now is I'm building a simulator so I have a simulator for the OpenHPSDR stuff, but I'm building a simulator to act like a Tangerine data engine. And we'll do a discovery and the kinds of things that I think need to be in the packet that comes back. And I'm trying to blend this as well as I can with all the documents that Bill has already written. So, and only change if there's something unworkable with the system, but I don't see that as being a problem. But one of the things, Tom and Scotty both brought this up, that there's stuff we need to know from the hardware that's the old system doesn't use. And the other thing is we're using a ping where we just took the next number out of the OpenHPSDR stuff. But if you read Protocol 2, they reserve that number for other use unless we ask for it.
That's not the way we do it.
Yeah. And so what I would suggest is we just pick a different ping value and not worry about it.
What do you mean by ping now? I mean, I know what it is, but how are we using it here?
We were using an EFFE 07.
Oh, okay.
So 7, 8, and 9 in the other protocol were listed as reserved. So that means the OpenH PSDR guys want to have some say in what those are used for. So
but Dave, once we get past the discovery, we're not really going to be following protocol.
No, so we could use any ping we wanted. And right now what I'm using is EFFE 0A, which is 10.
Is there a problem with using the same one they use?
They're
going to respond differently than we are, right?
Well, we'd have to sort, if somebody had open HPSDR radios on the same subnet, it would have to filter out which ones are which.
Well, Dave, the code that I wrote already does that.
Yeah, but what I'm doing that, but then I want to have multiple status values. So instead of just idle or running, I would like to have not programmed, but idle, running, those, something like that. We do need to have a list of the physical hardware that's attached. And I see that as RF1 and now RF2. And there's, if I understand right, we have 3 options on each of the RF boards. And I'm hoping Tom will straighten me out on this. RXRX, RXTX, and TXTX.
Yeah, in fact, Scotty had multiple, more options than that.
Okay. Well, I was going to start with that, and then we can add options.
You also need to know which kind of clock module is plugged in.
Then, so I had RF1, RF2, and then I had 3 values of clock modules, right?
Yeah. Please call them 0 and 1 and not a 1 and 2.
Oh, 0 and 1 for the RF board sockets. Okay. And then leaf.
Yes.
Some sort of reply from the leaf module.
Yeah.
And that would only be 1 leaf module at a time, right?
Correct.
And then you need something that pings the I²C, or at least somehow you figure out what signals you can send to the I²C.
Yeah, so once you know how it's equipped, you should know which modules, the modules will have a number, and and some modules will have 2 I²Cs, some may have none, some will have an I²C and an SPI. You'll have to have a table of equippage so that you can know what registers you can manipulate based upon what module's been plugged in to that slot.
Right.
Bill wrote the protocol for how to write and read those.
Right.
And I don't know if that's in the document yet, but Bill had a protocol that looked like it would do the job there.
Well, I mean, I've been going through his protocol, but I'm trying to fill in the details so that I can actually write the code.
Okay.
And I've been reading his code, but a lot of his code is what he needed to fix to do what he's doing. And what I'm trying to do is do what I have to do to talk to the FPGA.
Right. So I think there's a couple of extensions to the discovery response that could be used to convey status of the data engine to the host. Right.
Like hardware configuration responses, right?
Yes.
Yeah. That's
so the first one would be the hardware. And then once we put some values in, what I assume is that there's going to be like a multi-tiered process. So you aren't going to, the way we have all these pieces, there isn't going to be like an open HPSDR, just a standard piece of code that you plop into the FPGA, right?
right. There'll be custom loads depending on the science that you're trying to do.
Right.
But the idea is every one of those loads will have the, here is the configuration response built in. So
Yes.
that no matter what's loaded, you can still get the configuration.
But still you have to have a ping back that tells the computer software what they're talking to.
Right. So that's,
which is a software discovery as well.
Right. So, we talked about adding a field to the discovery response for, communicating the value of port A, because
Yes.
in Scotty's proposal, you have to know what port A is before you can talk to port A.
Right.
So you have to convey that back in the discovery response. You need some additional fields in the discovery response that say what all hardware was plugged into that thing anyway. And then I suggested some kind of a null terminated string after that, so you could figure out what kind of an FPGA load was on the data engine. So
Right.
you'd have some clue as to what you're doing there. There's enough room in that discovery response to put all those fields.
Oh, yes.
Is that
So
adequate, or do we do something else?
Not only FPGA load, but revision too, right?
Yeah, but it'll need
Yes.
to have a name. In HBSDR, there was just a load that had a revision. But in HAMSci, you'll have a load that's used, as a communication receiver. You might have a separate FPGA load for ionospheric sounding filtering. You might have a different load for some other science thing. So there could be 3 or 4 different kinds of loads, each of which would have a revision as well. So
Yes.
I think we need to add that kind of information.
And that's what I'm trying to do, is actually write the specific hex line that will go one way or the other way.
And I think Bill's point was to also try to make things ASCII, make things human readable. We don't need to
Well-
encode everything in hex that we don't have to.
Okay.
Is that a valid statement, Bill?
The idea, I mean, I don't know how important it is, but the idea that I had was that you could test this thing with a terminal.
Well, yes, I understand that. What I'm trying to do is based on what I know from OpenHPSDR, I'm trying to write, how do you talk to the FPGA? So
You're talking about hardware specific commands and
yes. Now in the FPGA, can you write an ASCII reply?
Yeah.
Or you said you were going to have a NIOS processor, right?
with a UART.
Okay.
So, well, it won't be a UART, but it'll be serial data going to the UDP stream. Actually, it'll be an ACT UDP stream, right?
So
Commands.
yeah. So I'll have to read some more about that.
So, well, I mean, the ACT is our particular construct, whatever we build it to. It's not
right. That's what I'm trying. So what I'm doing is I'm trying to write code that talks to something that isn't there yet.
Yeah.
And I'm trying to figure out how to write a simulator that acts the way we want it to act, so that it makes it easier to write the FPGA code.
because I'll be simulating
that
your
does
simulator.
what. So it's a chicken and egg problem.
Yeah.
Which one do you build first?
Here's another question to put in the back of your mind. We have a red and green bicolor LED aside next to each RF slot, RFM0 and RFM1. Now, the FPGA could figure out whether it's smart enough to know what RF module is plugged in there and know that the load will work with that board,
right,
and to light the red or green LED, or we can merely let the software query the hardware and then turn the red or green LED on, depending on whether it figures out that it's compatible or
right.
not.
So I'm kind of in the latter section, that I've been developing something that gets some basic query and then does a follow-up configuration query. So there's a basic query that's just what's physically plugged into the board set, because that's variable.
Okay.
And then once you have that, then you got to figure out, well, what kind of software is already there? And the bare minimum would be a bootloader. And there could already be an existing image.
Well, I would suggest that you don't have to ask about the bootloader, because if you can ping it, you've got a bootloader.
Right.
So
the bootloader is this hardware component, and that's what I'm working on right now.
Okay.
New country.
What was that?
That was just my computer saying so.
Okay. And I'm trying to stick to Bill's protocol as close as I can, but what I'm thinking about is something that comes in like his first line of his protocol. And I'm using the one that's off the website. Is that what or off your GitHub?
Right. Yeah.
And Bill, that's the one we worked out at Hamcation, right?
Right.
Yes.
And I also have been reading through line by line Bill's C code. So I'm paying attention to that.
So you know how he wanted it to work, and then you know how it really.
Yes. And so what I'm really trying to do is just make it so that I think before we get very far, we got to have a very clear description of what each thing does, how it talks to each other. And that'll make the whole world work a lot better.
This is where I got really stuck on HPSDR, because how do you describe all of the hardware? And you can say, okay, we can say how many ADDs do we have? What rates can we run them at? But then when you start saying, well, how many virtual receivers do I have? How many virtual receivers can I assign to each ADC? Then it gets really nasty really fast.
So essentially, there is this problem that you have a finite amount of space that you can put stuff in. And you'll have to write the code that could populate that space. But you also have to say, okay, once I've used up some of the space for something, that reduces the amount of total space available.
But basically all you want to know is how many resources do I have?
Yes.
Because if we plug in on the Data Engine Mark II next year, we put a CVA9 part that's 300,000 LEs, and we can do 80 virtual receivers at a time. We don't want to be limited by the protocol. We just want to make bigger tables.
Yes, right? And that's what I'm trying to do.
Yeah.
So anyway, I'm going through that, and I don't know. I'm assuming Bill and I should communicate about this. I've tried to communicate with Tom, and he keeps telling me to talk to Bill. So, and I haven't bothered you because you usually don't reply to my messages. So.
But I do like being kept in the loop, because if I see something that jumps out at me, I will reply.
Okay. But I don't see that we can get to even putting any code on the FPGA without getting this settled somewhere. Now it can change, but we need at least a shot at how it should work.
Yeah.
So Dave, is it possible to propose what you want to see in the discovery response in terms of the fields there?
Yes.
And ask Bill and Scotty and I and others to see if we agree with that.
Okay.
And then after we think we have enough, kind of the more static kind of information that comes back in that response, to see if we need additional things that reply with the more dynamic aspects of the configuration. Could we do it in that 2 steps?
Yes.
So could you propose what you want to see? And then
yes.
ask for comments?
I have roughly a piece of paper that has a bunch of that on it.
Okay.
So it's just making sure that it's complete and writing it out in a nice, neat way that you can read.
So Dave, what I'm hearing that Tom is saying is that we want to make it like hierarchical, perhaps?
Yes.
So that you say, well, hardware is there, and then you say
hardware.
And then you say, okay, now what's the configuration of this module?
Right.
Because now I know there's one of them there. So now I can ask about that one.
Yes.
Is that what Tom said? I'm hearing that sounds good.
Yes.
To make it a hierarchy.
It's a hierarchy thing. And eventually we'll get to the point where there's something running there and Bill's protocol can talk to it.
Yeah, so now on the static configuration, once you know what's out there, what's plugged into it, and importantly, the name of the FPGA load and revision number that's out there, you now know how to talk to the FPGA to ask it questions about how many channels do you have, Are they chirped or are they linear?
Right.
Those kind of questions, which could change from FPGA version to version.
Right.
The discovery response format should be version invariant.
Right.
And then what happens if you ask for something that you can't get an answer to, you get a knack back?
Well, if
I don't know what that is.
Yeah.
In the virtual.
The invariant response would tell you what's plugged in out there, and you ought to know you can't ask that load of code that question.
So you can't ask the receiver what kind of DAC rate it has.
Not until the appropriate FPGA load's been put on the data engine.
Right.
But even
That's
so,
the way.
you might ask something that's inappropriate, like the transmit rate of a receiver module. I mean, something that's not, that there's no answer to.
Right, but
you asked the wrong question.
Right, but that is what I call the variant part of the response. The invariant part of the response is something that everybody has to always do the same way. And part of that is the name of the FPGA load plus
Right.
the version. Then once you know that, you know how to ask the next level deeper of questions.
Right.
Because you know what loads out there.
And that's what I've been working on, is this very first step. It's like you've got an FPGA. We've used Quartus to put a bootloader in there. And now what?
And probably what's going to happen is in the FPGA loads, since we're anticipating many of them, eventually you're going to get to the point where the FPGA loads are going to be have modules. So
Right.
for instance, you'll have an FPGA load that will always have a bootloader, and then it might
Yes.
have a receiver module, it might have a
Yes.
transmitter module, it might have a VLF module, and if it doesn't have a VLF module and you plug in a VLF board, then
It just won't give you any response in that
Right.
particular query.
right.
Now,
This all sounds so much like SNMP.
It does, doesn't it? Yeah, 1.1.1.1.2.
yes. So I've been going around with this and trying to figure out kind of how to describe that. And so I'm at a point where I'm just about there. So within this next week, I'll have that description of the very first level,
Okay.
the hardware level.
Yeah. So what's coming back in the discovery response, we can
Right.
sort of agree on. And
Right.
then after that, then we can
And-
dive deeper.
And I will have working code of that too. So I have a simulator responding the way it should, and a programmer that discovers that software.
Okay,
So
very
you
good.
just give me the algorithm, and I'll code it in the FPGA, and then it'll all work, right?
Right.
I like it.
But I don't know it'll be that easy.
Okay.
But if I had never done this before, it'd be quite different. Than at least I have some idea how to go
Well,
about this.
We know it's going to be hard, but if it doesn't sound easy, then it'll be impossible.
Yeah.
Okay.
Something like that.
Dottie, I'm going to have to go here in a minute, but I'd like to propose something else additionally. I'd like you, David, and I to have an email discussion about the ADC IO to the data engine.
Okay.
I think there's a couple of more issues that might arise.
Yeah.
I think the three of us can go work that out independently.
Okay. Well, I'll send you guys the schematic, and then we can start with that, and then we
Okay.
could look at the IO document for the FPGA and the A to D, and then those are really the two pieces that we need to talk about.
Right.
Right. So I think the three of us can work that out maybe by next week or the week after.
Yeah.
Okay.
Sounds good.
So that's what I had.
That all sounds good.
So I think if we get to that point, we could either use the IQ2 or the development board that you and I have
Right.
to actually test out real FPGA code to see how it talks to your software.
That's why I'm trying to build the simulators, so that then once we put something in that development board, it should respond to the same software.
Yeah. And the code is the code. So when we move it to our board, it's the same FPGA.
Yes.
Well, it's the same family. It's
Family,
size.
yes.
It's a smaller pinned one, but it'll act the same.
That's my hope.
Yeah, it will. It's just that we have to change all the pinouts to agree. Well, actually, something that will be different is the Ethernet MAC. Well, Ethernet MAC will probably be the same, but the PHY is different, which is
Okay.
going to be a pain in the neck because you really want to program it for the PHY that we have. And I
Yeah.
don't have a development board that has any of that hardware on it until we get the actual data engine.
Now I have it. I maintain the Mac in the string, the hardware string, the discovery string.
Okay, well, that's part of the header, right?
Yeah.
Yeah.
The standard discovery response has the target MAC sent back.
Yes.
But I was talking about the actual Mac hardware that implements that function.
Okay.
It's going to be an IP that we're going to put in the FPGA, but it has to talk to the particular PHY that we pick, and there's tons of different PHYs.
Are
So-
we going to do the thing like the other where it just comes up, and then if you want to, you can program in a hard address?
An IP address, you mean? You could change
Yeah,
it?
in the hardware.
Yeah, I think we need that feature.
Okay.
That's part of the same as we had an HPSDR, right?
Right. So we have an example of that.
Yeah.
Yeah, right now on HPSDR, of course, the target gets its IP address from DHCP.
Right.
Well, there's
Right,
another
so it's
problem
not-
too, is that
So
all-
the IP address is not plugged in normally. It normally acquires it by a lease.
Yes. But then if you want, you can put a fixed address in
Okay.
Open HPSDR. Some people do it, some don't.
But another problem just occurred to me we're going to have that they didn't have with HPSDR, since it was basically 1 unit per bus per IP node. All the MAC addresses were the same. They were hard coded to the same string, which we
Yes.
did not do. So what I think I'll propose is we have the chip now on the board that has a unique serial number.
Right.
I would just take that and hash that and make a MAC address out of it. And because I don't have a block of MAC addresses that I can assign, we'd have to buy those, I think, is the way it works. I know for USB, you have to buy a block if you want address.
It used to be that you bought a organizationally unique identifier from IEEE, which is the first 3 octets of the MAC address. And then the last 3. They changed that recently, so you didn't have to buy a whole block, and there were sub blocks. So I don't know. That's all changed since I last bought a block of those.
Well, at Zephyr, we actually build and sell a Wi-Fi module that has to have a MAC address. And we bought a block of 16 million addresses.
Right.
And I'm wondering if we could use, because we only used a very few of them.
Yeah, I was going to say, if you have a OUI that you already own, what you should do is continue to use that, and then take some parameter from the board that you can hash into, a probably unique second set of 3 characters.
Yeah, because trying to, even if we had a block, which I think we do, to get those numbers assigned to individual pieces of hardware is not trivial.
Right, but
into each board separately and uniquely.
Yeah, but you can, if there's anything that you can get out of the board, like reading the double EEPROM and just doing some kind of hash function to try and come up with 3, the odds of a collision on the same local area network are, very, 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 very close to 0.
Well, we have 2 things actually. One, each FPGA has a unique ID number programmed, hard coded into it.
Okay.
So I forget how many bits it is. It's maybe 64 bits. It's some big long number.
Yeah.
Also, we have the encryption ROM that has a guaranteed unique 72-bit number.
Yeah.
So we would just hash that down to whatever the remaining bits are in our OUI, right?
Yeah. You hash that down to 24 least significant bits, and then use your existing OUI as the most significant 24.
So we could do that.
Yeah.
Okay. Well, we'll have a email
extravaganza.
Yeah, whatever it takes to get this fixed.
Yeah. So Yeah, it's time. We've delayed the documentation as long as we can.
Yes. I
Now-
just,
now
I
we need
really
to-
want to get it on paper, you know, specifically what these things are doing. And I want to use Bill's stuff that he has as much as possible. But this is before, it's like stuff we need for the hardware part before Bill's protocol thing.
Yeah.
Yeah, hopefully the invariant part will be really close to what Bill's already got.
Yes. And I'm thinking that's good.
Only
The-
change
the-
it if you need to. Only
What?
change it if you have. Only change it if you have to.
Right. So,
Sounds
and
good.
so, and it's nice to, but between Bill and I, we'll have working simulators for these things.
So on that note, let me see if I can share my screen. I'll show you what we got for the data engine. Can you see it?
Oh, yes.
Yes.
So this is the placement for the data engine. So you can see the clock module, we moved it over to the left side because it works better for the layout. So over here on the left, if you can see my cursor.
Yep. Yeah.
And we have room to grow it to the right some. This could be moved out of the way, this header. I think that's the programming header for the FPGA or the jumper selectors. Anyway, so we can move that out of the way and we can extend this over the top of whatever's underneath here. And the idea is that the clock module will have no components on the backside except for power bypasses. So no, and it's, I don't know how many layers it's going to be yet. The data engine is projected to be 10 layers, which is the stack up here. And this is just a preliminary guess to the stack up because we don't know which planes are going to have the control impedance calculation, control impedance lines on them and which ones don't. So this is a general starting point. This is very preliminary. The leaf is the blue outline board here that extends down to the M.2 connector here, and the Raspberry Pi header up here. So the red outline is the Raspberry Pi board, is a hat board, and the blue outline is a leaf board. That makes sense to you. Power connector in the upper left, stacked Ethernet connectors here, one over it's too high, 2 gigabit Ethernet ports, a USB 2 port here vertically, it's just upright, and then the USB 3 port is down below the clock module underneath because it's only a millimeter high or 2 millimeters high. And the FPGA being here in the center, and this is the DRAM right above it. And then over here is the micro SD card, which is small enough to fit underneath where the RF or the leaf module goes.
So Scotty, I have a question. If the RF boards are lapping under the other side, is there either a hole or a standoff or something to keep it from flopping on the other end?
Yes.
Yes. And that is actually these 2 holes right here.
Okay.
And then these 2 are for the other RF module.
Okay.
So they've got the connector on one end to support it, and then the 2 holes.
Okay, very good.
And then for the leaf module, you've got the 4 holes here.
Right.
In the corners. The clock module, you have the 1 hole here.
1 hole.
2 connector down here. This may move around depending on what the layout is, but there'll be 1 hole basically. And then this is the battery for the real-time clock over here. This is the optional buzzer, which I don't even know why it's there, but it's not going to be on the original. It'll be a place for it, but it won't be there. I put it on there because it was on the Lime SDR. And I don't know what they use it for, but hey, what the heck, you know. And then this is a fan header right here for using internal fans. So what we've done is we moved all the I/O over to the left side.
Yes.
So the top and the left are the I/O, and the right-hand side will be internal I/O, or like the SD card, there may be a slot there for you to plug it in, but there's not going to be, I mean, it's just a slot. There's no connector there. So it's flat on the board. And then the bottom is just the RF module. And I have this is the RF modules mated to the data engine. You can see the blue is the this is a top view, I believe, and the two RF boards are in blue. And interestingly enough, the RF boards are 115 millimeters tall, and the data engine is 100 tall. So you can see how this paths out here along the bottom. This is the connector on the RF module, and it actually solders down here, but the connector outline is this blue outline that comes way up here like this, so that these fingers plug into it.
Oh, okay.
So the connector is deep. It's like more than 10 millimeters deep, or like 15 millimeters. But as you can see, the black outline here is the board, is the data engine right here. It ends right here. And the RF module sticks down to here on the bottom and is even at the top. And these slots here, these are for end launch SMAs for the RF coming into the RF modules. And these blue things, these are the protection diodes for the relays that are mounted on top of the RF module. And you can see this is a problem right here, because this is the Ethernet module, the dual Ethernet module, and it's got through-hole pins. And the RF modules are only about 2 millimeters off of the data engine. And that's not enough for the height of the diode and the through holes of the connector. And I really don't want to make a requirement for the manufacturer to have to trim off these pins. So, and besides, when you're plugging the boards together, you don't want pins to catch on components. It's a bad thing.
Yeah.
So anyway, we may have to move this diode up just a little bit or over so it's in between these rows, or over so it's in between these rows, because these are all surface mount parts here. So at any rate, this is the thing that the 3D modeling helps us do, is avoid things like this that are going to catch on each other. And then
Scotty, where does the antenna connect to the clock module?
Off the side. So if we go back here, that's the rat's nest. But if we go back here, the clock module is down here. So we'll have SMAs coming off of this side, which is actually better than, we had them originally coming off the short side, but there's actually 3 connectors. So might likely have 1 down here and 2 up here, or maybe move this down a little bit and put all 3 of them up here. It's going to be really tight. We also have a 4th one that's a vertical one. That's this guy right here. That's the optional clock input if you want to feed a reference clock into the clock module and use that for your reference instead of the GPS.
Oh, okay.
And then we got a GPS antenna, and we have a PPS out and a clock out, I think, are the 3 SMAs that come off the side. Again, this is preliminary. Things are going to juggle around a little bit, but the main thing is, if you look at this, this is the rat's nest. This is what has to be connected. So you can see why
no problem.
Yeah, everything away from these connectors here, because he wants this general area in the middle here to be available for routing, because even at 10 layers, it's going to be challenging to do it.
I'll have my son Anthony work on that. He likes rearranging wires.
Okay. Probably better at it than we are.
He certainly knows what he wants to do.
Yeah, he'll graduate from university by the time he finishes.
Yes.
Yeah.
Think about doing that with multicolored pencils.
Oh.
Yeah. So one of the
I
things,
used to do that.
I took this to the Scorpions meeting, and then the guy says, well, can you really route wires over the top of each other like that? No, we can't. So, but the idea is too that they're color coded so that the purple wires can be pin swapped amongst themselves, but not amongst the cyan wires, not amongst the yellow wires. These are bank coded. So purple ones generally, although you have to do pairs, so you have to swap a differential pair. The N and the P are dedicated. So if you pick the N, you get the P automatically because they're together. But you can take those 2 pairs and swap them with each other, and to eliminate as many of the overlaps in routing as you can. And the guy that we have is an expert at this. We did a different board for another customer that had an FPGA on it, and we got the thing looking so good there were hardly any crossovers. And we did that one. That was only a 256 pin BGA, and we did that, I think, in only 6 layers. He did it. I didn't do anything except say, yeah, you can swap those. And then of course I have to go back to the schematic and swap them, which is a pain in the neck, but it's well worth it, because Otherwise, it may just not be possible within the number of layers. You could fix it by adding more layers, which then costs you every time you build the board, or you can put a little NRE in to straighten it out. So here it is, a trade-off. How much do we want to pay him versus how much do we want to reduce the cost of the board or not increase the cost of the board? But he's been doing this for as long as I've been doing engineering. So he's extremely good at this, and he can tell pretty much when he says it's going to take 10 layers, it's going to take 10 layers. And you can try to push him to 8 and he will just bitch constantly until you give up and give him his 10 layers back. And then he'll do it in the 10 layers. So he's good enough to know that this is what it's really going to take. So you're going to need this.
Well, is just a curiosity thing. Is there ever any issue with crosstalk between wires that cross over between layers? Crosstalk between the wires and the different layers?
Yeah, and typically you try to route adjacent layers perpendicular to each other to minimize that crosstalk. And if you have differential pairs like almost all of these are to the connectors, you route them very close together and very close to the ground plane, and you put a ground plane layer in between so that you get the return currents are, well, the return currents are typically in the wires, but if it's any single-ended signals, you want the return current to follow underneath the wire as it goes out across into the board. And one of the tricks is if you have split ground planes, you never let signals cross the split in the ground plane. So what you do is you put the sandwich the split ground plane in between, like say power and ground layers that are solid. Because if you run a wire from across the ground plane, the return current has to come back somewhere. And if it has to flow through that ground plane that's not part of its circuit, it's going to find a way to do it, and it's going to mess you up. So you want to try to avoid that as much as possible. And so it's like a big juggling act. I mean, you got all these pins down here that can be swapped. Then they have to go to the places they have to go. They can't be swapped over here. And you want to keep them away from the pins that are technically interfering with them. I mean, they're in the same group. You got to separate them by layer, and then you want to separate them by orientation, make them perpendicular. And it's a skill, I think, to be able to do this. And some people have it and some people don't. And I've worked with CAD guys who really I didn't think were that good because they couldn't visualize how it looked in their head. I mean, I think that if you're going to be a mechanical guy, you got to be able to take whatever you're building and 3D rotate it in your mind's eye and be able to see it. Otherwise, you're just not going to be able to do the job very well. And so a lot of this, just placing the parts on here, he's grouping the parts so that the groups of wires go kind of like in a bundle. And he doesn't put that one down here and that one up there so they cross over. And he's trying to keep areas separated as much as he can. So like there's a bunch of blue wires that go up here that go, this is the phi for the Ethernet. And I'm not even sure what a lot of these are. This would be the USB 3 controller. This is probably the USB 2 controller because it goes to this connector right here. And then this is the DRAM that we're going to have. These are the power supplies up in here. And I told them I don't like power supplies underneath the leaf board, but there's not really a lot that I can do. Although if Jonathan builds his VLF board, switching power supplies are not the thing you want next to your VLF board inputs, because they're likely to fall right in the input frequency range you're going to listen to. So what we're going to do is we're going to take these and we're going to cram them as far to the south as we can get them, so that when you plug the leaf board in, the analog part will be up here, but the digital part will be down here. Once you get it digitized, it won't interfere anymore. So that's about the best we can do. And again, it's all about trade-offs and doing the best you can. And then if we screw up, then we have to do another rev because we have to
presume they can't be put on the bottom side.
They can't be put on the bottom side because I don't want anything, especially switches on the bottom side facing the RF modules.
Right, that's true too.
Yeah,
Yep.
so, and we have a solid plane, almost a solid plane on the back of the data engine. Like I told them, R's and C's can go back there, but I don't want any components back there. And on the RF modules, no components on their back, they go back to back, no components on their backside. So basically you have two copper planes facing each other. So with a gap in between. So ideally we're going to get the best isolation that we can between the boards. And we made provision also we're going to make provision on these power supplies to put a shielding can over them. So that if we have to, we could put a can over them and to assist us in mitigating any RFI that we have from the switchers. But again, these switchers now, these are Empyrean switchers. These have built-in shielded inductors, and they're extremely low RF noise switchers. So
What switching rate?
I think they're 300K.
Okay.
No, they must be higher than that because the inductors are so small. I'm not sure what they are.
Yeah.
They're 3447s, EN 3447s, if you want to look them up.
Let me look.
3437 and 3447. And they cost a little bit more, but by the time you add up the cost of the inductor and a flywheel diode, you're paying the same amount anyway. And these are so nice because if you see this right here, this group of maybe 7 or 8 caps, these 3 caps here and that part, that's the whole power supply. Everything is right in this little group. And he hasn't done anything to minimize this yet. So he's going to lay these out around the power supply, and then he'll have a block that'll be pre-routed and you can just move it around. Same for these other supplies up here. There's 4 of them.
I'm not finding that number. What's the number again?
Second here, it's a 3337, I think. 1 second. It's really kind of stressful working on 3 different boards at the same time because, like CAD guy wrote to me, he says there's a problem with the decal name of J11, and I look on J11 and it's like the power connector he recommended that I use. So I mean, I know he's got the right decal. Well, he was talking about the clock module, not the data engine. So it was a different part number. So 1 second here, I will go to the data engine right here. And where am I? Okay, you have to close the program before you can reopen it again.
Oh, excuse me, gentlemen. I'm running down. I'm going to go QRT.
Yeah.
Okay.
If
Sorry.
anybody needs to get in touch with me, you should have my phone number. But that means you, Dave. If you
So
really
you're going to be included on this email that Tom and Dave and and I are going to be hashing on.
Okay. Good.
Is that good?
Yeah.
Okay.
73.
73.
73, Bill.
I need to go as well, so I'm going to go.
Okay. It's an EN 6337. Sorry.
EN?
Echo November 6337.
I'm sorry. I spoke at the same time you did.
EN 6337. Here, I'll put it up in the chat.
There we go.
Type.
Oh, okay. Oh, an Intel thingy.
Yeah, it's not Intel anymore because they sold off Empyrean. So
Oh.
I don't know what they call it anymore, but I designed this.
Well, comes up under Intel.
Yeah, it's still listed that way, I'm sure, because they sold it off in the past 6 months. And I designed these in before Intel sold off the division. So I'm using them anyway.
Okay. Let's bring up that data sheet.
And the beauty of this one is for the VCCIO, I basically used a separate regulator for each RF module. And then we have a jumper that programs it to either 1.8, 2.5, or 3.3 for that module. And that drives the VCCIO for that bank of FPGA that runs that module and also supplies power to that particular VCCIO pin. So, in fact, I can show that.
Switching frequency free running 1.9 megahertz.
Yep.
Right in the middle of the 160 meter band. But we can sync it externally anywhere from 1.5 to 2.3.
Means we can move it out of the band.
Yeah.
If we use this, I grounded the sync pin, but it's in auto LLM mode. And that allows it to go between, okay, now I'm gonna have to remember the two.
Yeah, I see its efficiency is good in that mode.
Yeah. But you see the jumper here, you can pick which voltage output you want. And then this goes to run the VCCIO bank and the VCCO pin on the RF module.
Uh-huh.
So that way I don't have to actually jumper any high current traces. I can jumper the reference, and then these are all hardwired.
Right.
Yeah, when you think about it, there's over 200.1 microfarad capacitors on this board. 217, I think, to be exact. And you know, I try to make the layout such that it will work. And so, you know, I'll take kind of like my ORCAD program. I'm just drawing lines, right? And I'll build a box that's 100 by 100, and it's just scaled, right? And then I take the big parts and I build a scale box for them, and I place them on the board to see if everything will fit, right? The trouble is that with 200 capacitors, you better leave a lot of space in here because there's a lot of things that go in there that you didn't show on your diagram. So yeah, I can get all the parts on the board, but there's no room for routing. There's no room for capacitors. There's no room for any of that stuff. It's like, for instance, on the back of the RAM, all these capacitors along here are going to go on the back right at the power pin to the ground plane.
Right.
I think we were talking about using 0201s there because of the fine pitch, and he's figured out a way. If you build the layout of the BGA, if you take the capacitor and you take the normal footprint and you cut the corners off of it, so the capacitor still fits, still centers itself, but the pads are a little bit smaller because the square corners are cut off. You can actually diagonally fit a capacitor between two pins, and the ground pin and the so you can get the capacitor right dead on the pin that needs to be bypassed, and it works great because
that's tricky.
It's very tricky. So then I went through on the design and I changed all the capacitors for the FPGA to 0201. He says, no, 0402s fit in between those pins because they're further apart. So I don't know what we're going to do this time. He's got this figured out, the bypassing. He's done at least a half a dozen designs with this kind of RAM and FPGA before. So I have pretty good confidence in that. So and like I said, just tonight we got a read-in of the clock module. That means all the parts that were on it, tentatively on it, are read in, so he can see if they're going to fit in the outline that we have. And the problem is, on this, what you're seeing here is this is data engine parts. This outline of the module is actually, I'm on the wrong screen, right? The outline of the module here. These parts are not on the module. This is an X-ray view.
That's underneath it.
Board. Right. So the problem is that the GPS module is like a third of the space. So the question really is, are we going to get both GPS modules on there? It'll be one or the other, but you have to have footprints for both. And unfortunately, one of them has a whole array of ground pads underneath it.
Oh dear.
Otherwise, they're small. One's small enough you can put it inside the other. And you can put either one, but you can't do that with all those ground pads there. So,
random idea is that could we make a little daughter card for that one?
It's possible we could stack them.
Yeah, so that we kind of hit the ground pads.
My preference would be to just extend the board out and put one here and one here. And then put all the rest of the good stuff down here.
Right.
Because then you start running into connector costs and assembly problems. And I know we've done, have you ever heard of an interposer module? So what happened is we had a guy come to us. This is an amazing story. We are Altera design partners. We've been with them for 20 years, right? When they first came out with the brand new, I think it was the the Stratix 1 probably, the new FPGA, and it was some big 1152 pin BGA or something. They put the wrong footprint up on the web page, and it was only there for a couple hours. Some customer loaded it and made a board using the wrong footprint.
Oof.
And of course, when they got their boards back and then figured out that it didn't work, they were really pissed off. So they, went to Altera and said, hey, you screwed us over. You cost us all this money. So Altera comes to us and they say, well, could you make us a PC board that's the size of the footprint of the FPGA with 1152 on the top and 1152 on the bottom, but they're all cross-connected. The pins are cross-connected. And we had to have blind and buried vias because we had to have a pin coming off of a ball on the top one that had to go over to the side, but you can't put a via all the way through because you got to have another routing layer. It was 28 layers. This thing. It was
wow.
It was 100. Regular boards 062. This was bigger than an 093 board in thickness, and had 28 layers. But the problem is, it costs like $10,000 for each unit because they're only building 10 of them. So they have to amortize all of the tooling, all of the engineering, all of the building of that little 28 layer module. And you have to put balls on the bottom, and then you have to solder on a BGA on the top. Oh, well, now you better use different temperature solder, or one operation is going to interfere with the other operation. So they had to use like some exotic temperature solder on the top to keep the BGA from falling off when they soldered it on the assembly on the board. And every step of the way, it was more money, more money, more money. But Altera paid for all of it because the customer was mad and Altera screwed up. And so they
assembled the boards before they found that out?
They assembled one of them at least.
Yeah, because at that point, I'd have just respun the board.
Well, that's what we suggested. But they apparently had built all of the, they had fabbed all the boards, and it was some big giant assembly that would cost to redo. And but most of the interposers we quoted after that, the customer ends up not doing because of the cost. Seems like a good idea, but it just is prohibitively expensive.
Yeah, so, well, I've hand wired adapters like that. Not for a BGA though, but for quad flat pack.
We had this rework girl at Motorola that was a genius. She took a 225 PGA. Remember the pin grid arrays?
Mm-hmm.
It had actual pins on the bottom, an array of pins, and you plug it into a machine socket. And what she did is the guy who laid the board out, the engineer gave, he got the bottom view instead of the top view. So the thing was mirrored.
Yep.
All the pins were mirrored. So she actually took a socket and rewired two sockets to cross the pins over from one side to the other.
Yep.
So these two sockets, the female one up here, she plug your part into, the male pin sticking down, and she wired from the male pins down to the male pins. And it was just like this sandwich of wires.
Yep.
And she got it to work. And the way I would do it is after the third wire, the fourth wire would break one of the first three, and then I go back to fix that, and it would break another one, and it would never work. But it looked like a wire wrap board in between, with just this mass of wires.
Right.
But she made the thing work. The patience of Job to get that to actually to wire that.
Yeah, I haven't done an adapter that big, but yes.
Yeah, that was the worst one I ever saw.
No, we did a lot of 56,000 designs. Those were pinned.
Flat packs are nasty too because they're narrow pitch.
Yep. Oh, very. Yeah, 0.5 pitch and wiring, soldering wires to it. Because what happened to us is we spun a board that the pinout was different for different footprints.
Oh no!
And it got mixed up, footprint and pinout. So and we had to get it prototyped. So a couple of these we hand wired while we respun the board.
Well, it's like on the magnetometer. That's a 50 mil part, and I had to swap two pins. like pins 2 and 3.
Right.
I gave up. I mean, I'm pretty good at rework. And it was just, I got 1 to work, 2 to work. Actually, you have to have 2 to test it, right? I got 2 to work, and then I said, okay, that's it. I took it into our CM, and I said, here, I'm going to pay you to do this because, and it comes back just beautifully done and tacked down, and just, it's not worth hacking it up yourself. Let the pros do it. So anyway, that's where we're at. Just thought it'd be interesting to, this is the most interesting one with all the wires on it. It's just unbelievable. But he comes back and he says, well, I'm not worried about that at all. Okay.
Yeah, that's a pretty straightforward routing job right there.
Yeah. So
that's very, so he did this placement? Is that what you're saying?
Yeah, well, we did it. I mean, we worked together, and he's the one though that came up with moving the clock module over to this side, because I had the clock module on the right, and and the lead.
I can see that was all going to be crossing over all that other stuff.
But then that's why I hire him, because he can see the stuff.
No, he's got a good eye.
Yeah,
I can tell.
So, yeah, we first worked on a project together in 1985, I think, 86.
Mm-hmm.
So he's almost ready for retirement now.
Ever tape a board?
Pardon me?
Ever tape a board?
I have, but he came in after the tape.
Yeah, well, I'm just asking. I mean, I date back to the tape and colored pencils days.
Tape and X-Acto knife, right? On vellum, on transparency. Yep. I built a double-sided 1K RAM board. I used 2102s. Remember 2102s? 1K by 1 RAM. So I had an array of 8 of them, and I actually managed to align the front and the back sides with 2 holes, and then the vias were just wires stuck in, soldered on both sides.
Mm-hmm.
I actually, it's a miracle I made the thing work. But I mean, I'm thinking 1K by 8, 1K byte memory. I mean, really? 1K byte?
1K bit memory.
No, it was eight chips.
1K byte. Oh, okay, yeah. So put together, but the 2102 was a 1K bit.
Right. So I used 8 of them. So I had 8K bits, 1K byte, and I was happy that I had this big memory. But of course, that was in what, like 1976?
Exactly. Yeah. My first computer had the 2K memory.
When 2708s, 1K by 16 EEPROMs were $100.
Yep.
And I remember a guy, he built a controller board for something, for one of the computers in the lab, and he got the layers reversed. So not reversed in order, but he got them flipped. So he ended up having to, I still can't believe this worked. He took the dip, it was all dips, right? He took the dips and he took the leads and he bent them back around this way and put them on the wrong side of the board, and then the pins lined up and he could solder them in.
Oh, you can do that once.
Oh my God. This is the guy that had a bunch of 2708s on his board, and he had some kind of 200 volt, the 5 volts had some kind of 200 volt DC offset on it. So he was scoping the board, right? But so the way he got around it was he put the scopes on an isolation transformer.
Right.
So that their ground pin of the scope could float to whatever you needed to. Well, some guy comes in while he's not there, needs the isolation transformer, takes it, plugs the scope into the wall.
Oh no.
He says, all the 2708, with the little windows, he said all the windows turned black because he put like 200 volts on the 5 volt line and just destroyed everything.
Well, the smoke didn't get out.
Oh, I think there must have been smoke. I mean, I don't know how it. But he said, the one guy told me too, that if you take a 2708 and you turn it upside down or 180 and plug it in upside down, that the bond wire glows for a short time. Until
for a short time
becomes an incandescent lamp.
Mm-hmm.
You don't want to know how he knows that.
Probably about the same way that you know that an electrolytic capacitor blows up if you plug it in the line.
Plug it in backwards, you mean?
No, if you take a polarized electrolytic and plug it into the wall, it explodes.
And why would you do that? For the explosion, right?
For the explosion.
Of course. Why would you drink Diet Coke and eat Mentos? I mean,
My friend decided to utilize that effect on New Year's Eve. And so he arranged it with the line cord and a rectifier and hooked it up to the capacitor. Came the moment he plugged it in, nothing. He had accidentally chosen the right polarity for the capacitor.
oh, well, 50-50, right? And you lose. Okay.
Well,
okay. I guess that's all I have. So it's getting pretty late here.
Yes, it is.
Same here.
Yeah, you guys on the east. Well, it'll be better. No, it'll be worse next time, won't it?
Doesn't make it. It doesn't really make.
It'll be the same next
Be
time.
the same. It'll be easier for me because it'll be an hour early.
You're the only, you're the only sane place.
Only sane place.
Clockwise. I heard the EU just abolished daylight savings. Did anyone hear that?
No, I didn't hear that.
I'm going to have to look at that. I think it's an ugly rumor, but.
By the way, Nathaniel, the QSO Today Ham Expo actually runs Friday and Saturday, and the talks are all on Saturday.
Okay.
So they probably won't have a lot of booth activity on Saturday. It'll be mostly on Friday. I don't know what that does for you. Makes it worse or better.
What time on Friday?
I don't know. I've got to find out what, because if it's open most of the day, I don't know. I've never done this before, so I don't know what the active time will be.
Maybe what we can do is we can, if we know what the times are, maybe we can come up with a controlled list of people who can come and help person the booth. And
like 1 hour shifts and get like 6 or 8 people. And
yeah, something like that. So I mean, maybe I could do a little bit of time. I'm sure I could commit Dev to do a little bit of time. I
could do some time, however useless I'll be for scientific stuff.
Hey, Nathaniel?
Yes, Greg?
I can send you the list. I'm helping Eric in some of the back office stuff, so.
Okay. That'd be great.
I can send you the times.
Yeah, if you send me the times, I guess, and how to how we participate, maybe we can get a couple people who would be willing to help out. I don't know.
We got hosts and co-hosts for all the presenters, and I've got all the times. I'll fire them off to you.
It's for the space symposium. It's a space forum. That's the one that invited us to come.
Okay.
The people from ORI that are doing it.
Yeah. Yeah. So I mean, maybe Hyomin can help out for a little bit. Maybe Jonathan Wood or David McGaw. As I said, I can try to do a little bit of it.
And I think, Greg, is it true that I mean, we might not have it all covered, but we would have, is there going to be a schedule for when like booths are manned as well as the talks?
Yeah, I'll fire it off what Eric sent to me.
Yeah.
Okay, because
I can copy you as well, Scotty.
If we have know exactly like what times and how to connect, then I can distribute it to an appropriate list of people who could help support it. Bill Lyles, he's into this sort of thing, and he would be very good. Steve Serwin would be a good person to have involved in this. We have a number of volunteers that.
So I've been talking to Michelle about it. She's the one that invited us. So I'll see if she wants to have multiple slots covered, or what exactly is she looking for. Since I've never done this before, I don't know whether she wants the whole day covered or if she's settled for just like an hour on each side of lunch or something. That'd be good.
Yeah, hopefully if you need like multiple hours covered, or even if not, I think if we could split up, we have a number of volunteers who know space weather things that would be good to spread the work out a little bit.
Okay, well, I'll get with her and see what she's expecting and then get back with you. And then I guess, because she's telling me she has to make a schedule up, but I mean, that's for speakers. I thought, I didn't really think there was a schedule for booth duty, but
Mhm.
that will be public. I mean, maybe it's just scheduled for her to make sure everything's covered.
Yeah. Yeah. Well, as I said, let me know and we can try to find people who could probably help out.
Okay. Yeah. Sorry, it's such short notice, and I really wish I'd gotten that chart out earlier to you for the suggestions.
That's
but,
okay. Everything's such short notice because we're all doing so much.
like I said, I was just going to blow it off, and then
Yeah.
no, there's 20,000 people going to show up. You need to do this.
Yeah.
Twist, you know. And so I said, okay, I guess it's important because
Yeah.
you want to get the word out. There's going to be a lot of people, I think, who will be seeing this for the first time.
Yeah. That sounds good.
Hey, Scotty.
Yeah.
Is your email address on QRZ? I don't have yours.
Yeah, you can. Well, here it can be Scotty@talks.com or WA2DFI@ARRL. I'll put it up here on the chat.
I got Nathaniel's.
Thank you.
I can spell it right. That's it there.
Yeah, Eric was scrambling for assistance, so I'm doing about 5 different time slots as hosting in the back office stuff. So he's looking for guys.
So you're like a moderator?
Yeah, we have a host and a co-host because if we get lots of questions, one guy can't handle it. So.
Yeah, so you want a couple guys on each talk?
Right. So I'm doing about 5 slots, but when I checked this morning, there was still a whole bunch of empty slots.
So is there just one thread of talks then on Saturday? And the talks are all on Saturday, right?
Yeah, I think there might be a couple on Friday night, but the bulk are on Saturday.
Okay, because I was looking on the website, and it looked like, at least for the amateur space radio, they have all their talks are on Saturday, and then they have a couple events in the evening, which we're not going to be associated with, and then they have the Friday booth open.
You're talking about this Saturday, this weekend?
This weekend, yeah.
Yeah. Yeah, it looks like they've got multiple tracks.
It runs on Sunday as well. So.
Oh, it does. Okay.
Yeah, I'm gonna fire all those times to you.
Okay, thanks.
Yeah.
Will be awesome. Another seminar, and then we got HamSci the week after.
Right. Busy.
And still trying to get boards out at the same time.
We had to make a decision with the HamSci workshop with the QSO Today Expo, because we were offered basically, do we want to be a part of the QSO Today Expo? And it was a very, very nice offer. But one of the things we wanted to do is we wanted to maintain our own identity as our own workshop. So we didn't really want to get assumed into something larger.
It would be kind of like if DCC merged with HamSci.
Yeah, but it'd be more like if DCC merged with Hamvention, I think.
Yeah, and get sucked up because they're big and we're little.
Right. Yeah. I think it'd be more like that. So and we just wanted to, since we're like we're an NSF sponsored project, and we just wanted to maintain our own identity as our own thing. So but then we also wanted to make sure we weren't competing against Ham Expo, because we don't want to. That would be bad too.
And did you see I put the NSF grants on the bottom of that poster?
I did. That looked wonderful. Thank you.
Hopefully it's not too small, but I want to get it all on one line.
Yeah, no, that's good. They don't ask for the numbers to be big. There's no, it's always, the acknowledgement's always small at the end, but they want it there.
So I haven't read all the emails for HamSci yet. Did you say you had a poster, a place we can go to build posters?
For the HamSci workshop?
Yes.
Yes. Do you want to do one?
I want to do one for Tangerine.
Oh, okay. Well, actually, I need to know that right now.
Oh, okay.
Actually, if I'd known that about a minute ago, it would have been better, because I just sent an email to the iPoster company saying, here's the updated list.
Oh.
But I think I can, they don't open, they're actually in Sweden. So.
Well, you want me to send it? Because
no. I have to be the one to send it.
Well, then tell them you're in the mountain time zone.
Yeah, no, I love it here. So here's what's going to happen. You are So you want this? You're the one that's going to be making this poster, right?
Right. This is using those tools that you demoed to us a couple months ago, right?
Yes.
Okay.
Scotty, so let me put you on this list right now, and let's get you added to this whole thing.
Now, once we get the poster made, is it pretty much captive for HamSci? We won't be able to take it out and use it anywhere else?
For 12 months is guaranteed to be available on their server.
But we just have to link to it then.
That's right.
Okay.
And in fact, and they tell us that for 12 months it's guaranteed there is guaranteed contractually to be available for 12 months. We are told that after those 12 months, it's still supposed to be on their servers forever, whatever that means. And as long as you have the direct link. If you don't know what the direct link is to it, then it goes, then you kind of lose it. But as long as you know what the direct link is.
You'll be able to search for it then. It won't appear in the search.
Right. But if you know the direct link, you'll still be able to get to it.
We could put the direct link on the web page.
Yes, and that's exactly what I'm doing.
Yeah.
So the answer is you should be able to keep working on it. So what I need from you right now is I have to grab from you. You're going to be Scotty@tonks.com. It's going to go to there, right?
Right.
The thing I really miss about the in-person workshops versus the virtual ones are the happy hours.
Yeah. You get a lot of communication done during that time.
It's so much fun. I agree. It is so
it's also the people that you see that you didn't know you needed to talk to, right?
I know.
Mm-hmm.
I know. All right. So, okay. Give me what do you want to call this poster?
I guess you could just call it TangerineSDR hardware.
TangerineSDR hardware.
Maybe I should call it architecture. TangerineSDR architecture. That would be better.
Architecture. Okay. And you want to present in English?
We.
Okay.
That's the extent of my French. So yes, it's going to be English.
All right.
Pig Latin.
That's it. So all my input's going to be in equations. So.
Okay. And then can you send me a 1-paragraph abstract for this thing?
I can.
Okay. With a
I
co-author
can do it
list.
in the next 10 minutes, right? So.
Yes. Well, I mean, you can do that.
I better do it in 10 minutes because otherwise I'll
Yes.
forget and then it'll be like 3
Exactly.
days. It'll be too late.
Again, abstract and co-author list. And I'm going to send, and I have to figure out which breakout
Because
room
basically what I'm going to do is I'm just going to take pictures from my 18 different slide decks that I presented over the years and paste them into pictures like what that poster was.
That sounds very, very good.
Thank you.
I'm glad you told me about this. And incidentally, I actually really want to use this poster session thing because we're actually, for a lot of reasons, but I went through a lot of trouble to get this contract set up for this thing. So I want to actually make sure we do good things with it.
If we get to use it for a year, it'll be a really good way to get to just like a short, concise description of the hardware out.
Yeah.
Are we able to edit it after the event?
Yes, I think up for a certain time. And I can certainly, I think since I'm kind of the account owner, I can tell them that I want you to be able to edit it for longer.
Okay. I don't know that I'll have to, but especially as things go along, if it's going to be there a year, we'll have updates and things.
Yeah. I may actually, I mean, now that I think of it, I have a bunch of money I can spend on this. So, I mean, maybe I can extend the contract to like 2 years or 3 years or whatever. But because I have plenty of money to do that.
I'm presuming that after 1 year, no more editing because it's just a static link and that's all you get.
Yeah, and then after a year, you'd want to make a new poster anyway.
Yeah, yeah.
So let me.
Well, it's good to have plenty of money, that's for sure.
Yeah.
Amazing how much you save when you don't have to rent hotels and catering and
Well,
fly
that's
in and
that's the thing. I had a budget for an in-person workshop where you are flying everyone in and putting them all up in hotel rooms, and all of a sudden you are not doing that. So
But the virtual happy hours are not the same.
the virtual happy hours are not the same.
they are not the same.
I was looking forward to Scranton, and then this whole schmozzle started.
I'm really hopeful that we can have it in Scranton in person next year.
I'm hopeful we can do DCC in September.
That would be so nice.
That's a little iffy, but you know, and I was not looking forward to going all the way to the East Coast last year for 2020.
Uh-huh.
So I'm going like, oh yes, it's going to be virtual. And now this year I'm going like, gee, I hope it's not virtual. I hope we get to actually go there.
Well, we have some really, I really want people to to see our campus, and I want people, and we have this really awesome hotel, this Radisson Lackawanna Hotel. It's an old Lackawanna line train station, like one of those grand old train stations that they
Yeah, that was
converted
where I was
into.
going to stay at until I got
Yeah.
canceled, right? Dang.
Yeah. I
Steve
know.
Bible's probably just as mad too because he's a train nut.
I know. And then you have the Steamtown National Historic Site. I mean,
Oh,
it's,
is that where Steamtown went? Oh,
Yeah.
yes. I want to go. It used to be up here, and I never got to it
oh,
until they moved.
yeah.
What?
So yeah, so we have it. I have to figure out, okay, Scotty,
I'll have
what
to
breakout room?
figure that in when we get there.
There's a friend of mine that I knew in high school. He was a couple years ahead of me, so he was pretty much graduated by the time I was in high school. And he was a train. I mean, this is a definition of a train nut. Okay, this guy, he built his own railroad. He called the Delaware, Susquehanna, and Northeastern DS&NE Railroad, which is totally fictitious. He printed up timetables for all the schedules for all the towns that it went through, and then he went down to the local cop supply store and he bought a whole railroad policeman's uniform. I don't know how he finagled the badge out of him, but he got a fake badge and he would go down to the rail lines, and he would just hang out and pretend like he was a railroad policeman. What was really cool was I had this terrible history teacher in 9th grade, and apparently he gave her a fake railroad pass for the Penn Central Railroad, and she tried to use it and she got caught. And I'm like, good for you. Miss Graham got arrested for using a fake railroad pass. Couldn't happen to a nicer teacher. And then when you would disparage his railway, he would get very upset and say he had the best railroad in the state and blah, 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 blah. And I mean, he took it very seriously. So
I have a high school classmate who, to this day, I think has all the schedules memorized.
Wow.
Across the United States.
One of
Probably
my
Europe too.
One of my
I
ham
know him.
friends from grad school, who's been to Hamvention a number of times, Kenny, he was a train nut. In fact, his call sign I think is K4NNW, which is Northwestern or Norfolk Northwestern. So yeah, he even got his call sign around. So Scotty, the question for you. For these iPosters, I'm breaking them up into breakout rooms, and I've been trying to split the breakout rooms so that there's no more than, say, 5 posters per breakout room, and that the posters are more or less grouped by similar topics. And
I'm just looking at it as who do I want to hang out with and who do I, I'd like to be in room 2, please. Hang out with David and Christina, but it doesn't really fit there. So
well, it doesn't really fit anywhere because none of them are really hardware posters. So
have you put the title in?
Two might be just as good as any of the others.
Have you put the title in already? Can you change it?
Sure.
Because I'm thinking maybe it would be TangerineSDR. I mean, TangerineSDR, personal space weather, PSWS hardware, or something like that. I got to link it to Personal Space Weather Station somehow.
Personal Space Weather Station.
TangerineSDR for Personal Space Weather Station. How about that?
Tangerine SDR for the ham sci personal space
Yes.
weather station. How about that?
I like it.
Okay, so that's gonna go to the poster company. Now here's how I do this. So next thing I do is I'll put you in poster room, breakout room 2. And then I can explain how I'm planning this breakout room thing to work out. This is gonna be an experience.
Actually, did you have John in there somewhere? N8UR?
Not as a poster. Does he want a poster?
Oh, no. I just thought I saw, he's a presenter then, right?
Yes, he's a presenter.
He's right after me. Because I was going to say, if he's talking about the clock module, he has a poster on it, then it belongs with that one. But he doesn't have a poster, so.
No, you are the only hardware poster, it looks like.
Oh, boy.
I think.
That's like when I went to GNU Radio Conference.
Uh-huh.
This is when we were in Atlanta, I think in 2000, I forget what year it was, 10 years ago maybe. And I think one of the few hardware presenters that was there. And I mean, these are all young genius software guys, okay, in this group. And you look out and their eyes are like glazing over because they really don't care much about hardware. They're all software guys.
Oh man.
It was kind of, and I went from being one of the youngest guys in the room to being way the oldest guy in the room when GNU Radio, all the old hams left and all the new young software guys showed up, and I was the oldest guy.
I think I remember you telling me this story.
Yeah.
If there weren't hardware, their software would be pretty useless.
That's right.
This is true.
We had a feud between the hardware and software guys at Motorola when I was there, and the software guys snuck in and said, software makes hardware happen. They had their CAD guy design a poster, big poster that they put up on the wall, said software makes hardware happen. So we had our CAD guy make up a poster that says, without hardware, software is just a dream.
Mm-hmm.
And we put it up right next to theirs.
By the way, referring to our previous conversation, people who are into the railroads are called ferroequinologists.
Ferroequinologists. I like that.
All
right, so now I have.
I would just thought they were called nuts. You know.
Okay, so I have it. I have it linked now.
Uh-oh.
So you are now in iPoster breakout room 2.
Oh my God! So now I have to make something.
Okay, so here's how I envision this working. So starting at noon, we're gonna switch over from the webinar format.
This is on Saturday now, right?
This is on Saturday. Yeah, we'll switch over from the webinar, and we're going to go to a Zoom meeting link. Okay, and the Zoom meeting link will support up to 1,000 people.
Okay.
And I can set up breakout rooms, which I think we played with a couple weeks ago, right?
So these breakout rooms appear simultaneously, right?
Yeah, I'll actually set up. I have 7 listed right now, but I'll probably set up like 20 or something. So I can actually do that right now.
So that means when I go into room 2, I'm not in any of the other rooms, and they're. So the 1,000 people would be distributed amongst all the rooms depending on what their interest is, right?
Right. So like right now, I just opened up 25 breakout rooms.
Oh my
God. And you can
God.
choose which one you want to go to. So at the beginning of the session, what I'll do is I'll explain to everyone how this works. I'll say, okay, if you go to this website, these are the different posters that are available. So for the first hour, what you do is you go to that room, and then each presenter will have, 5 to 10 minutes to present what their poster is about. And then it's open discussion. And I'll assign a moderator to each room.
But now we got 1, 2, 3, 4, 5. So that means each person gets 5 minutes. So that's 25 minutes plus Q&A. And then, but all of the people in this room are looking at all of these posters, right?
That's right.
So how do if I go to this breakout room, how do I pick which poster to look at, or am I fed the poster that the person's talking about?
Well, during their time that they're giving their talk, you're being fed the poster.
Okay.
But at the same time, I will have, it's not there yet, but I will have it so that when you click on one of these, there will be another link here that says URL, and you'll actually be able to go visit that particular poster.
Okay, but that will be just looking at it. That won't be talking to the creator then.
Right. So,
Okay.
but this will give each creator, 5 to 10 minutes to talk to a group of people.
Okay, but us 5 creators are all in the bullpen together, and while I'm
Yes.
talking, they can't talk, and vice versa, or they shouldn't talk.
That's right.
Okay.
Okay.
And then at the end, will you have like a Q&A for anyone then who wants to?
And then after that first, like, say, hour where people are going over their posters, then it's a free-for-all.
But they're still separate rooms though, right?
They are, but you can jump between whatever room you want. So you can either hang out your poster in this breakout room, or you could go somewhere else.
And
But
go
now,
ask someone about their poster. Okay, I got it.
right. Now, can you, when you're looking at, so if you look at the breakout room list right now, if you click the breakout rooms, are you able to see who's in each breakout room?
How do you know? I mean, I'm just looking at your screen.
Click on your control button on the bottom. Do you have a button that says breakout room?
Well, don't I have to point my browser there? I mean, I'm just looking at your screen
No,
on here.
on your Zoom.
Oh,
So if you stop looking at my browser, stop looking at my screen.
Oh yeah, I have breakout rooms.
And do you see everyone's name in the list there?
If I click it, I see, oh yeah, room 1 through 25, and Mike's in room 1.
Okay, so you can see that.
Yes.
All right.
Then
So
I gotta
now,
pop over here to join any one of the rooms I want.
right. So basically, after that first hour where people are presenting their posters in an organized fashion, then it's a free-for-all. So now people can play with this breakout room feature, and you can go chase people down.
So if I were to say go to room 5 and say join,
yes,
then what am I going to see? Am I going to see anything that signifies the 5 posters, or am I just going to see the 5 people?
You'll just see the people in the room.
Okay. Okay.
Okay.
And then I take it, since I could see that Michael was in room 1, you'll be able to look down the list and see who's where and try to. This ought to be fun.
Right. And then you can
playing whack-a-mole.
Exactly. And then, like, let's say you want to have a side conversation with someone, you could like direct message them, or you could go track them down in their breakout room and be like, hey, can you meet me in breakout room, 30 or whatever, or 25. And then you can have a side conversation with that person in a separate breakout room.
We should rename these to channels 1 through 23, and then they could be like a CB.
Well, we could do that too. It doesn't let me. The problem with it'd be nice if it would let me rename the rooms on the fly, but in order for me to rename the rooms, I have to close them down and then rename them and then open them up.
Oh.
So like,
so how do you open up 25 rooms? You have to enter 25 names first and then open them?
No, that's a piece of cake. I just click breakout room over here, and then I can choose. Here, I can actually make you.
But then you can't name them. You just get room 1 through N, right?
Here, you're now a co-host. Can you make your own breakout rooms now?
Let's see. Breakout rooms. Add a room. Yeah. But it just adds the next number. Okay, wait, can I change the name? Rename, yeah.
And like when you first do it, when you first set up the breakout rooms, it asks how many rooms do you want to have, and you can do up to 50 of them.
So you can add 50, but then you got to go one at a time and rename them all.
Yeah, so that's why I'm not going to do that.
Yeah. Well, look at this. There's a button that says open all rooms.
Yeah. So yeah, click that. Now people have the ability to go to the different rooms.
Oh, I see. So this is allowing them into the rooms I just created. Okay.
Yeah. And so this way, yeah, so at least if I create like 25 or 50 rooms or however many I want, then it gives space where we have the first, 1 through 7 rooms. That's going to be where we have the organized presentations for the first hour or so. And then after that first hour, it's a free-for-all. People can go have side conversations in different rooms.
So more like happy hour.
Yeah. Yeah.
Except not so happy.
You have to bring your own cocktails.
Yeah. So, if you don't have a good time in happy hour, it's your own fault because you're supposed to bring your own stuff.
That's right. Yes. Yeah. But I really wanted to make this the workshop more interactive, even though it was online. And so I thought this would be a way to do it.
Yeah. Sounds like fun. It'll be interesting to see how it works.
Yeah, it's going to be an experiment. I don't know. I think it'll be good, but it could be a disaster.
Yeah. Well, I think it'll, even if it doesn't work out the way you think it will, it still will be fun because it'll be interesting. Because
Yeah.
everybody gets to choose their own way to go.
Right.
So it's just like walking away from one group and talking to another group.
Exactly. Yeah, so it should be a really interesting way of interacting and talking.
Because I can just see it. There's Bob McGuire. Bye, click, and then you're gone.
But now you can actually see where everyone goes.
Yeah, that's true. So you can't hide. You could
can't
change
really-
your name though to McDuff or something, and then nobody know who you were.
You could do that, yes.
You could do on the QT, and so nobody would. We remember, Dan, we used to have people like that on TeamSpeak, who would they'd put like Mickey Mouse up, or they'd put some name that nobody knew, just so they could listen without having us know who they were.
Yeah, that's true. But usually you could figure out over time who the heck they were. Yeah, I remember that.
Sneaky people.
Yeah. So let's see.
Okay,
Well, that's
sounds
good.
cool.
I'm
hope-
glad
I'm
you're
looking
going to do
forward
a
it.
poster.
And let's see. So this is Friday and Saturday, right? No, nothing on
Yes.
Sunday, right?
Nothing on Sunday.
But it's good. Of course, it's going to start at 6 a.m. on Friday for me. 8 a.m.
Oh,
right?
I'm sorry.
Eastern time. I know. It's funny. Somebody was bitching at me. Why are all these conferences all on Eastern time? It's people on the West Coast, right?
Uh-huh.
And they said, and I found one that was actually on Pacific time.
Uh-huh.
And so it's like it just depends on where the organizers live. They pick
Yeah.
the time zone, their own time zone.
Which I've thought about that too, but now I have people participating from Germany and Norway and
But now they want to be a particular time for them because
right. Our keynote speaker is in London.
yeah, so afternoon's not so good for him. It's the middle of the evening.
Yeah, her. She'll be she's at 5:30, Eastern time, so it's gonna be like I don't know, 10, 11 o'clock at night for her.
Oh no, that's England's only like 5 hours from the East Coast.
Yeah, so if she's supposed to start talking at 5:30 here,
Oh,
it's
in
gonna
the
be
evening.
10:30 at night for her.
Yeah.
Yeah.
Well, we had one of our board members on Tapper is in Sydney,
Mm-hmm.
and so I don't know what it's like plus 15 for us. So even at 8 in the morning, it's midnight for him.
Yeah.
Or something like that. It's late.
Yeah. So it is it is quite the experience.
Well, with global conferencing like this, you just figure out when you have to be awake, and then you just have to be there, and that's the way it is.
Yeah, I know. It's just kind of
Too bad. I guess I don't know. I think it's being up in the middle of the night for one night is still better than jet lag for flying somewhere and being there for like 4 days. And just about the time you get acclimated, then you turn around and go back home.
Yeah. Yes.
And you won't lose your luggage.
Luggage. Or if they do, then it's it's your own baggage handler's fault. So
But doing
should be
all
you.
this organizing, it's a lot of work for this. I don't know that it's I'm not sure that's actually any easier than an in-person. I guess it is, but it's
different because you're just sitting at your computer most of the time instead of going and talking to people, right?
yeah, which like my whole life now is pretty much sitting in front of a computer.
That's right.
So which I love using computers, but
well, we're going to see too as I get my second COVID vaccine on Tuesday night.
Mm-hmm.
So if what happens this time is like it happened last time, I'm going to be grumpy. Even on Friday.
You're getting it when?
I'm getting it on Tuesday night.
Tuesday night. Okay.
11 o'clock at night.
Oh boy. 11 at night. Why 11 at night?
Because they schedule, well, that was an early one. They schedule them 24 hours. And
Oh,
when
wow.
and actually it turns out they said for the second shot, you can come in anytime within like 4 hours of your time.
Huh.
They don't care. But
Okay.
it was, let's see, I think it was actually at 10:45 or 10:48 was the scheduled time. But it's nice because there's no traffic. Everything, I mean, we drove right in and right up, and the longest wait we had was the wait that we have to wait afterwards to see that there's no side effects, that they make
Wow.
you wait in line. They write the time in a marker, in a dry erase marker on your windshield,
Mm-hmm.
and you have to stay there until that time is up.
Wow.
So when they give you the shot, they write 15 minutes later on the windshield, and then you have to wait.
Huh.
And because I guess there's people that do have bad reactions.
Yeah.
We didn't have them, but
Yeah.
then they let us go, and really, other than that wait, there was no waiting, and it was, you would not believe it. It's a stadium. Okay, this is a football stadium. Okay,
Mm-hmm.
in one of the giant parking lots,
Mm-hmm.
and they put cones and tape, do not cross tape, and they make a rat's or maze, and they have volunteers with flashlights at every corner. So there's a guy there going that way, and then they take you and they split you into multiple lanes when you have to go in and fill out a form or talk to somebody, and then you come down to only a couple lanes, and then they spread you out into more lanes when there's a wait involved. So when we got to the place where we actually got the shot, they took us out of this tent, which is a couple lanes, and they spread us out into like 8 lanes wide. And they had a guy there directing you over there, you over there, you over there. You were like shuffling cards, like dealing cards.
Yeah.
So we were only in a line of maybe 3 people, and then they had about 4 post-shot spots to park. So that means that was only about 4 minutes per slot opening up. So it moved pretty fast.
Wow.
It was amazing. I think we could have gone at 2 in the afternoon when it was mobbed, and it would have been the same.
Yeah.
Because they were ready.
Wow. It really helps when they're organized.
Yeah, and really it was like I was in there, it was at night, so you couldn't see anything, right? You have to, you can't tell where to go with the cones everywhere. So
Yeah.
I'm just driving straight until they point me to go a particular direction.
Yeah.
And there's no problem.
No.
So, and I talked to some of the people, and they are all volunteers.
Wow.
They all I mean, not the people actually doing the shot,
But the people doing the traffic control.
Right, but the traffic control was all volunteers, and all the people came in, the people to question you, like, do you have any allergies? Do you have any reactions to medication, to fill out their little forms? They had volunteers doing that. They had like iPads, and they would fill them out.
Wow.
And they want to know, is this your first one or your second one? Because some people sneak in for the second one, even though they're not supposed to be doing that at this place.
Yeah.
And then when you get up to the front, they give you the assignment for your second shot right there.
Yeah.
They give you the date, 3 weeks from the same date.
Yeah.
But they said the timing is much more lax for that one. Like I said, you can show up 4 hours early for it if you want.
Okay.
So I think we'll go a little earlier, but not a lot, because traffic's much easier at 8 o'clock at night than it is at 6 o'clock.
Yeah.
Because that stadium is like 40 miles from our house.
Okay. So it takes you a little bit of time to get there.
Takes some time to get there. Takes like 45 minutes to an hour, depending on the traffic.
Yeah.
You guys are ahead of us. I'm an essential worker, and I haven't had mine yet.
Really? And you're in Canada?
Yeah.
So are they giving it to above 70-year-olds yet? 75?
Well, my dad's 95. He gets his tomorrow.
Wow.
And
who was it that John Gibbons said that they just opened it up for 50 where he is, and it's mayhem. I mean, it's like, there's so many people that are eligible now.
Yeah. They finally in New Jersey, they just opened it up for teachers on Friday. So my sister was able to get her first shot yesterday.
Well, aren't you able to get yours?
Nope.
Even though you're a teacher? I mean, a professor?
I'm in a different state. The rules in Pennsylvania are different from New Jersey.
Oh, right.
And I think I'm not sure. Sometimes to differentiate K-12 educators from college. I think
Would it just
Pennsylvania.
depend on whether you're required to go in and teach in person or not?
I don't know. But I think in Pennsylvania I'm considered an educator, but I'm not sure. I think New Jersey, when I looked at the rules, I think it said K-12. So I'm not sure.
Oh. So Greg, what do you do?
I work for a large electrical utility.
Okay, so are you considered an essential worker then or not?
Yeah, well, electricity, basically, if you don't keep the lights on, all chaos breaks loose. So we're essential workers.
So then do you get the ability to get vaccinated earlier?
Well, as I just said a minute ago, we're not even scheduled yet, and I'm an essential workers.
Wow. So you're in like the first group then. And you're
Yeah,
now getting-
I'm 60. I'm 60. Just turned 60. I'll get a little bit of priority, but nothing like my dad. So
over 75 is ahead of essential
that's
workers.
right. Yeah.
Okay. Because I know in here they had group 1A and 1B, and 1A was essential work was healthcare workers, not even schools or essential workers. They were just healthcare workers. And 1B was essential workers and anyone over 75. And then they decided that they weren't getting enough people coming in, so they lowered it to 65. And then they got a whole bunch of people come in, and now I think it's still sitting at 65 at 1B. They haven't opened it to group 2 yet. But
Can I ask you questions about the Tapper merchandise?
Sure.
Okay.
I mean, I know the answer.
Are you familiar with this device?
Oh, for pure signal. Oh, that was an HPSDR thing. I'm vaguely familiar with that.
Okay.
I have one sitting right in front
Oh,
of
there's your expert right there.
Okay. So Phil Erickson pointed this out to me. Would this work if I need a TR switch to protect my receive stack from my transmitter? So I have right now I have an antenna switch, a manual antenna switch. I have my ICOM IC7410 100-watt class transceiver sitting on the desk, and below me I have my my Grape PSWS, my red Pitaya, which is running as a whisper, or I mean an RBN receiver, my Edis USRP with advanced receiver, advanced research receiver, preamp running, and something else as well. That's all going through splitters. Would this be appropriate to put in line so that when I transmit, it protects the receive equipment?
Oh, come on. I'm on the page now looking for.
It almost looks like a scaled down red Pitaya in a sense with all the ports.
I think the answer is yes, Phil.
I think the answer is yes, but I was trying to not say yes until I actually looked at it to see if it might actually work.
Phil Erickson told me it would. I just have not had time to actually read it. And
well, Phil must know, you know.
Yeah. No,
Does he have an HPSDR system? Or
This was a John Ackerman deal.
Yeah. So John would be the person to ask.
Yeah, if he would. Because the purpose of this is really to sample the transmit signal, isn't it, Dan?
Yes. Yeah, there's a little bit of leakage through the switch, and you can use it to do pure signal.
So that also, there's a little bit of leakage that comes out of the sampler.
Yes.
So that also means, could you then attach the sampler to a scope or a spectrum analyzer?
Yes. Yeah, it's used for adaptive pre-distortion, or what is called pure signal. And it's basically a way of distorting the transmit waveform in such a way that it comes out as a better signal.
Yes, you read down here, it says it's important that the sample signal is at least 10 dB stronger than any leakage or crosstalk for the rest of the transmitter chain. Because of course you want to get the output, not any intermediate stages.
Yeah.
Because that's what, if you're using pure signal, that's what you're going to correct. That's what's going to determine your correction factor is the feedback
actual
of the transmitter. Yeah.
Okay, so then the receive stack gets connected to that. Okay, so that's the sampler.
It's a general purpose TR switch and requires only 12 volts and a standard ground on transmit keying signal, which I'm sure you said you had a 7610.
Yeah.
I'm sure that'll provide the amp keying output will provide
Which
that.
goes right there.
Yeah.
So this is basically all set to go.
Yeah.
Okay. Is there a chassis case that you know of that would fit this nice and easily?
Not that I'm aware of. It comes as a kit. It doesn't come assembled.
But there's no enclosure.
There's no enclosure.
Yeah.
And the TAD enclosures are all way too big.
What's this?
You can ask John though. John might know of an off-the-shelf something that you could actually drill up to put this in that would fit it.
Yeah.
Yeah, it doesn't actually have any mounting holes on it. So
yeah, it doesn't, does it?
Yeah, but you could. It does have enough room on the edges that you could slide it into a slot.
Well, it also has screw ferrules for the connectors.
Yeah, that's
you
true.
Could, you could, if you drilled the holes, you could slide those in and put nuts on them. And although what I would do is I would put 2 nuts on the SMAs because you want it to be the bottom nut to give you a surface that's the same height as the 2 BNCs. And then put another nut on the outside to clamp it to the panel.
Yeah, that makes sense.
Because it looks like the SMAs are in a little bit further than the BNCs are.
Yeah. Yeah, that makes a lot of sense.
That looks like the TR switch circuitry stolen off of the filter boards, which is actually a good thing.
I think that's exactly what it is.
Yeah.
Does anybody know where the feedback signal goes in the transmitter chain?
It goes to the receiver. The receiver and the transmitter are running at the same time.
Yeah, they're full duplex. So you use the receiver to listen to the transmitter to get the error signal to invert and feed back in with the transmitter to correct it.
Okay.
So you're using your receiver while you're transmitting as kind of a monitor.
Daniel, you may want to sequence that like they do with transverters and moon bounce so that your relay is switched over before your transmitter energizes and vice versa, that the transmitter turns off before you let go of the relay.
And hopefully the amp key output of your 7610 will key before it starts producing power. That's what it's designed to do anyway.
Right, yeah, because it's supposed, right.
So like Mike says, no hot switching of the relays. It'll destroy them pretty fast.
Well, you're trying to keep RF away from the receiver.
Yeah.
Yeah.
But you also don't want to switch the antenna while the RF's on.
No.
That's aside from your receiver blowing up.
Presumably the output, that keying output of the 7410 would be sequenced appropriately.
Right, and you get like 50 milliseconds or something before RF comes out.
Yeah.
I've seen a bunch of VHF bricks that's the antenna switching relays were all burned up. Well, they use RF sensing to key the relay. And by the time the relay's keyed, I mean, there's plenty of RF there to burn the contacts.
Yeah.
Yeah, I never really believed in RF sensing or, you know, the small amps you could buy, like the Hard Rock 50 that you could set up for automatic band switching. So it actually measures the frequency coming in and switch the PA to that band.
Yeah.
So There's no band switching because it automatically senses it. Well, that sounds like a loser to me because, like Joe says, it has to get RF before you actually switch things, and then you're switching it hot. So I don't think that's a good idea.
It works. I mean, I've used it
for a while.
Yeah, for a little while.
Well, I don't know.
The relay contacts sitting there bouncing while you've got RF on it. That's not real good for the contacts.
Besides, we all like wires. Wire it all up. It was like Jim used to say, we'd set up the whole contest station on 160, and we had 2 stations and an alpha amplifier in between, and we had a foot switch that would switch the radios between the amplifier input. So the amplifier connected to the transmit antenna, and then we had one guy, whoever had the transmitter would get that receive antenna, but the other guy would get all the beverages, so he could listen on 160 while the other guy was transmitting. And the beverages were so uncoupled from the vertical transmit antenna that you could actually listen in the same band on the beverage antenna, a long, low wire, horizontal wire, at the same time as the other guy was transmitting. But God, what a mess of wires it took. So we'd look in the back and he'd say, I thought they called this wireless. And there's this pile of cables.
Come to mind?
Pardon me?
Rat's nest come to mind?
Rat's nest, yeah. I like that. Rat hole, it's supposed to be a rat hole. It's perfect. And you just don't walk back there because it's got all kind of coaxes and everything. And either you trip or you tread on some coaxes, which would not be good for them.
Or you.
Or you, yeah.
I've got an awful lot of projects going at once here, and I've got coax RG58 all over the shack.
On the floor?
Yeah, on the floor, halfway between the desk and the floor, and just almost everywhere.
I used to work with this guy named John Zentner at Wright-Patterson Air Force Base in the RFI department. So before we could fly our LED lights for the KC-135, we had to prove that they would not interfere with any of the avionics on board the aircraft. So we had to take them there, and he would test them. And that guy, if you tread on one of his coax cables, you were in deep pucky because he guarded those cables but they were laying all over the floor. And so you had to just like tippy-toe around because you better not put your foot on one of them. So he should keep his cables out from under my feet is what he should do. But we got even with that guy because I don't know if any of you guys are military guys, but do you know how they keep toolboxes in the military? How they have in the drawers, they have foam cutouts for every tool. And like when you're working on an aircraft, you can't accidentally leave your screwdriver inside some critical place. So what they do is every night before they close up, they go through every drawer of the tool chest and make sure every hole is filled. And if every hole is filled, then all your tools are in the toolbox and none of them are on the airplane where they shouldn't be. And he was bitching because he says, well, I'm not a line mechanic. I don't work on aircraft. I got my own RFI shop. I shouldn't have to follow this stupid procedure of putting all the tools in the exact right places. So we went down to the local parts emporium, the surplus place, and we found a tool. And get this, it was a screwdriver with the end cut off. So it was a plastic handle with the shaft, but there was no blade. And I don't know what the thing was for, whether it was used for a drift or anyway, it was 10 cents at the surplus store. So we bought it and we would go in the next day and we just set it on the guy's bench. Well, now this is a tool that there's no hole for, right? Because it's an extra tool that we put on his bench. He goes to clean his bench up and he has this extra tool and he's never seen it before. He doesn't know what it is. And he's like, where does it go? He looks through his toolbox 3 times trying to find the place where this tool goes. And so then the next day he accuses us of doing, well, he's not sure, right? So he's asking if maybe, did we bring in an extra tool and left it on his bench? And we're both saying, straight face, no, well, of course not. And then the guy I was with, his name was John, he starts laughing and then the jig was up and he knew it was us. The only thing that saved us is we left the next day, so we didn't have time to get retaliated against because he would have found something to do to us that would not be fun. but we got them good.
I was with a aviation group, and one night the people from another squadron went over and took one of the airplanes, and they painted a different side number on it, and they moved it. And it took a week to find that airplane.
Oh, no.
We had a missing aircraft.
Oh, and it's sitting right over there, but it's painted with a different number.
Yep, put different tail number on it.
Did anybody get in trouble for that?
I didn't. I didn't ask.
Well, the KC-135 that they put our LED lights on, the colonel at the Air National Guard, which is where it was stationed in Phoenix Sky Harbor, it was the 100th anniversary of Arizona. So he actually, this I don't understand how they did this either, because he had to actually take the tail section off of the aircraft, and he painted the state flag on the tail, on both sides of the tail. But he had to take it, and do you know how much gear there is in the tail? I mean, all the mechanical, it's all hydraulic, and all of the boom operators controls and all that all had to come off, and he had to take the tail off. And apparently after he didn't ask permission to do it. And apparently after he did it, he kind of got in hot water for doing this thing without any authorization. But I tell you what, that plane flew all over the world, and you could tell immediately whose it was. And in fact, it was funny because it was coming into Washington, D.C., and the guys on the ground had no idea what the state flag of Arizona looked like. They thought it was some kind of UAE bigwig flying in. I mean, come on a tanker, right? He's not flying on a tanker. But they got all in a knot over this official plane coming in because, oh, look how it's painted. It must be official. It has this big flag on the back of it. And all it was our state flag.
Gosh. Oh, boy.
Colonel Culp was his name. And he's retired now. Too bad. He was a good guy. Because he, I'm sure he asked and he couldn't get an answer. So he just said, well, screw it. I'm going to do it myself then. And he just went and did it. Better to ask forgiveness than permission, right?
Yep. That sometimes works wonders.
Yeah. He didn't get fired or demoted. I guess, can they really fire you? I guess they can discipline you, but.
Do it and then beg for forgiveness.
Yeah. Well, this is a great thing. It's going to show off our Air National Guard unit, blah, 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 blah. And it was unmistakable. I wish I still had a picture of it because.
Don't try that with your spouse.
Yeah. Usually in that case, it's not better to ask for forgiveness, right? Let's see. KC-135. If you do it, just a KC-135 search and go to images, I bet you will find it. It's so distinctive. We actually had a picture of it, and I don't remember the website anymore, but there's a website that you can track planes by tail numbers.
Oh, yeah.
Dan, you might know about that because I think you're the one that told me about it.
Well, if you put in a tail number and do a Google search engine, you'll probably come up with that site.
Yeah, if I can, I can't remember the tail number though. So it's like 30.
Yeah, but you'll come up with the name of the site, and you can do a search on that then.
Oh, okay.
I don't know.
Yeah, I think that airplane flew under the call sign Copper 8.
Copper 8?
Yeah. Yeah, I saw it one day on my ADSB receiver because they do not put military airplanes on the FlightAware network, but if you have a receiver, it does give you the information for the airplane. Since it actually reads a code off the ADSB receiver. Everyone has a unique code, and every receiver is assigned to a specific airplane.
Oh, right, because this squadron is called the Copperheads.
The Copperheads.
So it would be copper and then a number of.
Yeah. So I think that flag is off of the tail of that airplane now.
It is now. They had to take it off because that was 2012 was the anniversary.
Yeah.
So, but still, they I mean, you think that there would be,
let's see here,
a list of Stratotankers or something that, oh well, I'll find it and put it up to next week. Here you go. For only $279, you can buy on eBay. You can buy a model of a KC-135.
Yeah, the airplane's.
Are we
called
talking something that flies?
No, it's just a plastic model.
Okay.
But that's pretty expensive for. I mean, I want an RC model for that kind of money.
Yeah, that's what I would expect.
I've got a link to the picture of it here.
P.T. Barnum had something to say about expensive items.
Copy.
So can you share your screen, Dan?
Yeah, I'll put a link on it. Let's see here.
There it is. Here you go.
Yeah, there's a link with it.
There it is right there on the right.
Yep, that's it.
Oh my gosh.
Yeah, it was kind of against protocol because they try to make military aircraft as individual aircraft unidentifiable.
Yeah.
That
It's
didn't work.
called the Spirit of Arizona.
Yeah.
Yeah. Yeah, because they don't want to draw attention to any particular aircraft, right?
Right. Yeah, I think that was kind of the downfall of the Red Baron, was it not?
Everybody knew his plane?
Yeah, they had a red airplane, and that was the only one, and everybody was on the lookout for him.
Didn't he have a swastika on his?
I think this was before swastika.
That was World War I, wasn't it?
Yeah. Yes.
I think he had the Iron Cross on it.
I'm trying to get a picture of anybody that I might know, actually. See, I don't know if I know those two guys. No, don't look familiar. But that you can imagine trying to take that tail off. Unbolt it from the aircraft. Holy crap. And I've been inside the plane and seen all the stuff that's up inside it. Yeehaw. I wouldn't want to be the mechanics that had to work on that. But if you can see, let's see if you can actually get a close-up enough to see one of the lights that we actually designed for the thing. We designed the light that goes on the tip of the wing, which you can't really see here, and the lights that slide in the boom nozzle back here on the back. And then there's one at the base of the tail, which I haven't been able to get a good picture of. But we designed LED replacements for all those bulbs. And it's scary because actually what you can see is underneath. So you see these strips along here and underneath the plane. Those are actually panels that light up. And they tell the refueling aircraft that he has to move up, down, left, or right to keep the boom still attached, okay? And all of those are powered by these horrible incandescent bulbs that flicker and make and break contact. And I have a lot of respect for those pilots flying this 1950s technology with lights that blink on and off. And they said that the bulbs in these they call them pilot director indicators, and the PDI bulbs, they last 50 hours of flight time. So basically, they're changing the bulbs out every time they go out. And so they asked us, well, what's the longevity of your LED lights? And we kind of mumble 50,000 hours. And they're going like, the plane won't even fly that number of hours until it's scrapped. There's not 50,000 hours left on any of these planes of flight time. So basically, you're going to put these in and they're going to be there and they're never going to be changed again.
Somebody's out of a job.
Somebody's out. The mechanics loved it because they said it was a pain in the ass to get to the bulbs on the PDIs. They had to unbolt them and fold them down to get to the lamps. And even when they changed them, a lot of times they would flicker during flight because the contacts were so. I mean, it was just like an automotive lamp socket. It was the big bayonet type. And so you can imagine if you're in an aircraft with, I mean, a jet like this, the whole plane is vibrating and the lamps are flickering, and oh man, it was something else.
When I first went in the service, I was working on P5MC planes, and then you got an additional bit of contamination from salt water getting into everything.
Oh, and that probably eats everything away.
Yep. We dumped a plane in the water, and all 4 engines quit, and one can only guess what happened there. Somebody flipped the wrong switch, I suspect. But anyway, we dumped a plane in the water. It was really an interesting situation because it was anti-submarine P2, and they put it in the water just off San Diego. And at the same time, there was a Coast Guard cutter out there with a whole bunch of airline stewards and stewardess on there being given lectures and ditching at sea procedures. They thought
real life example right behind him, right?
Yeah, they put the plane down right next to the cutter, and everybody jumped out in the rubber life rafts and paddled over to the Coast Guard cutter and climbed aboard, and the plane sank. And we sent a big crane out there the next day and picked the thing up out of the it wasn't very deep, and picked it up and took it back, and never ever got any of the electronics to work again. Absolutely nothing.
Oh yes. Well, so it was basically spare mechanical parts after that. Nothing else.
Yeah, scrap.
Scrap. Jeez. Well, okay. That's all the Arizona photos there are. But when it was flying, we tracked this all over the world with that website, and it was pretty cool to see. It flew to Turkey. It flew all around the Middle East. I don't know what they were doing. It flew up to the North Pacific Northwest. And of course, it was wherever it went, it was obvious this was the plane. Oh, wait, look at this. I'm thinking, oh, that's a strobe light. Never mind. I thought, wow, they actually have a picture of our light on the web. Well, okay, I can do better than that. Then it's time to QRT here. Let's see. Here you go. So this is the original wingtip lamp. And this is the same as the PDI light. It's got a reflective coating on the back and a regular bayonet base and not really a lens, but a bulb coming out and facing forward. And this is what we replaced it with. This is a series of LEDs and a pedestal. And this, by the way, this is incandescent only. This was NVIS friendly LED and infrared. And we could also flash it or dim it, similar to what they did with their rheostats. And interestingly enough, some of the lamps are run on AC and some of them are run on DC. So the AC ones would actually have an auto transformer with a wiper. And the DC ones would have, I don't know how they actually did it. They did steps instead of rheostats, I think. Anyway, we did steps and we modulated. And the trick was this whole thing ran on one wire. I mean, you had the airframe as a return, but we weren't allowed to add any wiring to the plane. So we had to encode everything. So we used subaudible tones that encoded the flash or IR or whatever it was onto the single wire. And then here you go. Here's the PDIs down here on the underbelly of the aircraft. And these were so bright, they made us turn the brightness down because they said they're too bright. They interfere with the pilot's ability to see them at night because they bloom in their goggles. So there's up, down on the left and forward and aft on the right, telling the pilot which way to go. Actually, that's John Martin, I think. These are the AFRL guys. But this was the hardest one because it turns out that this lamp up here did not meet FIR regulations. So when they wanted to fly a KC-135 into Europe, they had serious trouble because the lighting was not correct. Because you have limitations as to how far aft the wingtip lights shine. So because one's red and one's green, right? You don't want to see the red one on the wrong side. So you have to make sure that no red light bleeds over onto the other side of where the green one is, which is why we had to have a flat piece. This is actually a piece of reflective material of like chrome tape, not really tape, but it's a piece of chrome metal with the sticky back. And then we put LEDs sticking straight out and LEDs tilted forward, that this then reflected the light back out this way and gave us the required pattern. And we ended up having to simulate this at great expense on the computers to prove that we would meet the regulations. And then once we did build it, we had to go into the hangar. And this is great. They hang paper and they duct tape it, the hangar closed, so no light gets in. So this is, even in the Phoenix daytime, you go in this hangar and it's totally black because they blacked it out. And then they take their optometers and they go around and each take readings every 10 degrees all the way around the plane and graph the actual response of your lights to see if they meet the regulations.
Oh, safety.
Yeah, so this was a fun project. Then we did all that work right back in 2012. Never came to anything. They had 500 planes that they were going to outfit with this system. And every one of the pilots I saw wanted it, but none of the management really took it up. And I think it's kind of like an NSF grant. You know, you have to have a champion who's really going to go fight for it. And we didn't have that, so it just kind of died on the vine. So anyway, that's the story, and I'm sticking to it. It was a fun project, but it would have been more fun if they'd actually bought $70 million worth of them. I'd be retired. Yeah, I'd be retired now.
That would be really nice.
You know, you work on every one and you hope one of them catches, and none of them do, then you're out of luck.
Huh.
But I remember this is, we installed these on the aircraft and we had trouble with the 400 hertz AC system interfering with our subaudible tones.
Oh, ouch.
And we picked tones that were like prime number divisors off of the 400. I mean, we didn't just do it blindly. We did it with some intelligence. But part of the problem was, and it was the, it was the PDIs that were the problem, because they ran the wiring for these up the side of the aircraft inside, and then they ran in this bundle of wires. No kidding, the bundle's like 1.5 inches in diameter, all the way to the rear of the aircraft where it connected up to the pilot director controls. So in that bundle was a whole bunch of power for something that was at 400 hertz that coupled right onto our lines. And it was a nice, good, 50 feet of wire coupling into our 50 feet of wire, parallel, tightly bundled together. So what we did is we took wire and we disconnected the wire in the aircraft, and we laid the wire on the ground. We ran it up back to the back and in the back hatch and hooked it up, and it worked perfectly. But when you put the wire back into the harness, it doesn't work. So, and the problem is I couldn't simulate the problem on the bench in the lab. So how do you fix something you can't demonstrate? You don't know what's happening. So at any rate, what I finally did was I took another set of boards, another board from over here, the lab, and I got a 400 hertz oscillator, and I drove a huge big driver at 400 hertz and I just injected 400 hertz right onto our line, and I could turn that up till it failed. And then you know how we actually fixed this? This is amazing. We fixed it in software by changing the frequency slightly. And it was a PSOC which had programmable filters that we could program in the software. So we fixed it in software. But to know that it actually worked, we had to demonstrate that it would fail first. And then we had to demonstrate that our fix would. So this is a great story too. We had another guy named Colonel Brown. He was from Tucson, and we were behind schedule and blah, blah, blah. So he was going to come on. He was going to straighten all of us flunkies out because we were behind schedule and we were slackers. So he kept asking me, when is it going to be done? When is it going to be done? And I would tell him, well, as soon as I find the problem, I'll let you know. I mean, I don't answer to him, right? I don't salute him, but you got to be reasonably nice to these guys. So he decided that 3 o'clock was the deadline for, and they were going to scrap the entire project if we didn't have something working by 3:01. So he calls me up at 2 o'clock and he says, well, you got this thing done? I go, no, I'm still working on it. I'm almost there. He says, well, we got to move on this. We got to cancel this. I said, no, you're not going to cancel it. You gave me till 3 o'clock and I'm taking every minute of my hour that's left to do this. And I don't think he was used to being talked to like that, because if you're a colonel, nobody subordinate to you talks to you like that. So, but he gave me the hour. I demanded it and he gave it to me and I made it work. And it was just, still to me, it's amazing that we pulled that off and we didn't get canceled. But geez, I had to fight for every minute. And man, that's been 8 years ago. It's much more fun now. The SDR is much more fun now. Okay, well, what is it? Oh my goodness. You guys are still awake?
Barely. I need to
I'm gonna
go.
let you go.
I got a lot of emailing done in the meantime here, which was
Okay, so how long do I have to do this poster, Nathaniel?
so we want you to quote unquote publish it by March 16th. You can still make
you're 2 weeks away. It's the other one that's next week. Okay.
Yeah.
This week. Okay. So 16th is the day I get my shot, so that'll be easy to remember.
Yeah.
So I'm going to make sure to do it before that, just in case.
Right. And there's this webinar tomorrow at 2 p.m. Eastern where they tell you how to make the iPosters.
So is there a Thursday seminar this week or no?
No.
Okay. I haven't checked into that in so long, but there's still the Thursday morning one, right?
Yes.
Okay. Okay. Well, thanks for putting up with my reminiscing over the old days.
Oh, it's fun.
Okay. I guess we'll say 73 and I'll get to work on the poster tomorrow.
Thank you so much, Scotty.
Well, thank you for putting it in at the last minute. I saw all your emails. I go, yeah, I got to read those. And there was emails coming from John and Tom, and I'm going like they're talking about the clock module, the changes need to be made. I go, I got to read that first, and then the meeting comes up.
How many hours a day do you spend on emails?
Oh, a couple hours at least.
Yeah, right.
If I only spend a couple hours, usually I'm delinquent because I don't read everything. So,
I know that, like, you spend so much time.
So I don't know how you get how do we get the time to do that? And then you spend 12 hours working.
It's crazy. I mean, I'm not sure.
That's one of the things. That's the only downside of home office.
Yeah.
Is the work is always there.
Yeah.
And if you just want to get to the end, it could just suck you to the point where you can't do anything else.
Yeah. It is absolutely true.
But I'm not really that good at managing my time, so I tend to get focused and distracted on one particular thing, and then other things get kind of behind. And
Yeah. Yeah. Oh well.
okay.
All right, Scotty. Thank you so
All right.
much.
7-3s, everyone.
7-3.
3 singular 7-3.
7-3. Have a good night.
Okay, I'll call you tomorrow, Dan.
Okay, great.
Because we got to talk about some things, and
Yes, yeah.
I can do it when I'm awake.
Okay, sounds good. Yeah, sounds good.
Okay, 7-3.
Talk to you later.
Everybody have a good night.
Bye.
All right.